A huge round of applause for our distinguished guests. Thank you, sir. Good morning, ladies and gentlemen. It is indeed a privilege to extend a warm and graceful welcome to all our distinguished dignitaries, respected professors, colleagues, research scholars, and dear students. As Albert Einstein once said, knowledge will bring you the opportunity to make a difference, but imagination and innovation will create the future. Guided by this spirit, we gather here today to celebrate ideas, research, and innovation. On behalf of Department of Electrical and Electronics Engineering, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, I, Dr. Anjali Jain, take immense pleasure in welcoming you all to the 6th International Conference on Recent Developments in Control, Automation and Power Engineering, RDCPAE 2025. On behalf of Organizing Committee, it is my honor to extend a very cordial welcome to our esteemed guest, Dr. Cecil Kumar Wadu, Senior Professor, University of Moratuwa, Sri Lanka. A huge round of applause. Dr. Prahlad Wadakepat, Deputy Director, Robotics and Machine Intelligence, National University of Singapore. Dr. Mohammad Rihan, Director General, National Institute of Solar Energy, Ministry of New and Renewable Energy, Government of India. A huge round of applause. Shri Moolchand Chauhan, Chair, Delhi Local Network Institution of Engineering and Technology, IIT UK, and former General Manager, North Central Railways, Indian Railways. A huge round of applause for sir. Professor Dr. W. Silva Murthy, President, STIF. Professor Dr. Manoj Kumar Pandey, Director, Amity School of Engineering and Technology. Professor Dr. K.M. Soni, Deputy Dean, Engineering and Technology. Professor Dr. P.M. Tiwari, Head of Department, Electrical and Electronics Engineering, Amity School of Engineering and Technology. So, huge round of applause for all our dignitaries. This two-day conference serves as a vibrant platform to deliberate upon emerging frontiers in control, automation, robotics, renewable energy, power electronics, artificial intelligence, and intelligent computational technologies. Just like its past successful editions, RDCPAE 2025 promises an exciting lineup of speakers, plenary sessions, and technical discussions. We are confident that all the participants will make the most of this opportunity, drawing inspiration and insights to apply in their professional and academic journeys. With this, I request all the dignitaries to please step forward for lighting of lamp. And light is a symbol of wisdom and prosperity. To make this evening a blessed one, we invoke Goddess Saraswati by kindling the lamp of knowledge and wisdom. To mark the auspicious beginning of RDCPAE 2025, we request the dignitaries to come forward for lighting of lamp while our ears rejoice to the chants of the melody of Saraswati Vandana, invoking Goddess Saraswati, the divine source of knowledge.
हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ। हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ। तू स्वर की देवी, ये संगीत तुझसे, हर शब्द तेरा है, हर गीत तुझसे। तू स्वर की देवी है, संगीत तुझसे, हर शब्द तेरा है, हर गीत तुझसे। हम हैं अकेले, हम हैं अधूरे, तेरी शरण में हमें तार दे माँ। हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ। अज्ञानता से हमें तार दे माँ। अज्ञानता से हमें तार दे माँ।
Thank you to all the dignitaries. Now I invite Professor Dr. Manoj Kumar Pandey, Director, Amity School of Engineering and Technology, Amity University, Uttar Pradesh, Noida, and co-patron RDCAPE 2025, without whose constant guidance this conference would not have been possible. Sir, I request you to please deliver the welcome address.
Thank you, Dr. Anjali. Good morning to all. Let's have a huge round of applause for all our delegates or our guests this morning. And we are really thankful to them for sparing their valuable time. And they had come in person to attend this important conference. So, first of all, I would like to welcome our Honorable Founder President, sir. Because of him and because of his motivation, we organize such a wonderful and relevant, important conferences in MIT School of Engineering and Technology and across. Would like to welcome our Honorable Chancellor, Dr. Atul Chauhan, sir. And on behalf of all the MIT family, we would like to welcome our guest of honor today, Dr. Sushil Kumaravadu. With a huge round of applause, please. And Senior Professor, University of Amattuga, Sri Lanka. Our guest of honor, Dr. Prahlad, is Deputy Director, Robotics and Machine Intelligence, National University of Singapore. Dr. Rehan, he is going to join us shortly. And Sri M.C. Chauhan, who is Chair of Delhi Local Network, Institute of Engineers. And our own Dr. Salva Murthy, sir, Honorable Vice Chancellor, Madam, who is again a motivating for all of us. Dr. Salamurthy sir, President of MIT Science Technology Innovation Foundation, would like to welcome all the distinguished speakers, those who had spared and they are coming to present their work and share their experiences among all of us. Just for the sake of information of the guest this morning, would like to just highlight some of the points of MIT Group of Education Institutions that was established 12 universities across the country, and we have 150 institutions, 25 schools and preschools. We have 17 offshore campuses in almost many of the countries of the world, and imparting the quality education in the field of various transnational and technical world. And we are the leading technical university and MIT University leading private university and focus mainly on the quality teaching, research, innovation in the latest areas of engineering and technology, science and technology management, and other disciplinary, interdisciplinary and transdisciplinary areas. MIT School of Engineering and Technology, we have 7 departments. We are imparting the education in 7 departments: Department of Computer Science Engineering, Department of Information Technology, Electronics and Communication Engineering, Civil Engineering, Electrical and Electronics Engineering, Mechanical Engineering, Civil Engineering, and Artificial Intelligence. Keeping this tradition of MIT Universe in mind and the vision of Honorable Founder President Sir and Honorable Chancellor Sir, this conference will be devoted to the recent advancement in electrical electronics in the areas of how the automation design and the power engineering is working on, control automation and power engineering. And the conference is again, it will be deliberating on how the national and international status of the renewable energies, the electrical vehicles, and the control and design system is going on. So in this 6th edition of conference, we have received 285 submissions, out of which the 7 that Dr. Tiwari is going to highlight more on that. A total of 75 papers has been registered and will be presented. And but if you just see about how the area of the control and automation and the power engineering is evolving across the year. Starting from the 3rd industrial revolution happens in the beginning of 20th century when the people are working on the RLCs, and that have its own limitations. And the RLCs and the automation happen across the country, and the machine time and the heavy engineering works and the automation was happening across the world. So and how that was being transferred into the programmable logic control, and how the PLCs, uh, uh, transformed the way how the controls of the machining is happening. Uh, Now there are a lot of challenges happens in between when the computerization happened, because the control and automation of the machines was beyond and before the computerization. And then there is a requirement happened when there is a uniform protocol was to be identified, which can remotely work into the automation and control of the devices. And of course, yes, the power sectors, power engineering, and power delivery and power systems as well. So there are challenges in the market for how we can create a common protocol which can be adopted by all the fraternities, all the people, those who are using the common devices. And these challenges were being well taken by the computerization when the various type of protocols, especially the TCP and IP protocol, was being developed in maybe 1990 or somewhere like that. So that the automation and control become, because again, the SCADA plays an important role when you have to be supervise all the control systems, including your RLC or PLCs. So, and that now the time is when the artificial intelligence is disrupting the whole system, including the power electronics and control systems as well. So now the challenge is, and the focus must be, how these disruptive technologies can be useful for the area of civil engineering as well, because we cannot leave the artificial intelligence effect into this particular area, and how the professionals requirement can be fulfilled with uh, the complete and very dedicated knowledge of these technologies in the world. So I'm sure that these 2 days conference will be highlighting and focusing on some of the issues, some of the areas which really is, because now uh, the time of smartness is happening. Every device is getting smart. Every system is going to be smart. And now in that smart system, how you can include these smart process into the various electrical devices and electrical systems will be the next challenge in front of all the researchers, those who are there. So, and I really congratulate and the team, RDCAP, Dr. PM Tiwari, and all the faculty members, those who have tirelessly worked for the success of this event. And with his limited resources, he has wonderfully organized this. I must be really congratulate. Okay, let's have a huge round of applause for the team RDCAP and the student volunteers, especially those. I can see they are working day and night, and bringing this concept into reality really require a lot of effort all across. So, my appreciation to all the student volunteers, faculty volunteers, and I'm sure that this conference is going to bring the new research ideas, new collaborations, and it's going to be setting new heights in the area of the control, the automation, the power engineering, for which the main the theme of the conference, because a lot of work is due to be done in these areas, because the focus right now is into the machine learning, the artificial intelligence, and all these type of technologies. But yes, how we can how these technologies can serve into the power engineering control system is still a long due is there. So I'm sure that since we are the outcome driven university, and I hope that all of us will be enriched by the knowledge and the experiences that we are going to gain during the conference, and that is going to set the new directions and making new contacts, new networks. So with this, once again, I would like to welcome all of you to this Temple of Learning. Thank you very much.
Thank you, sir, for your kind words and visionary thoughts. Every accomplishment begins with the decision to try. May I now request Professor Dr. P.M. Tiwari, Head EEE, Amity School of Engineering and Technology, and Conference Chair RDCAPE 2025, to introduce the theme and highlight the vision behind this conference.
So, thank you, Dr. Anjali, and it's indeed honor to come as a conference chair in RDCAPE 2025. A very good morning to all of you who have joined here in person as well as virtually those who have joined. Honorable Founder President, sir, esteemed Chancellor, sir, respected Vice Chancellor, Madam, respected W. Selva Murthy, sir, President ASTIF, our distinguished guest of honors, Dr. Cecil Kumar Wadu, Senior Professor, University of Moratuwa, Sri Lanka, Dr. Rehan, Director General, National Institute of Solar Energy, Ministry of New and Renewable Energy, Government of India, Dr. Prahlad Vadakipat, Deputy Director, Machine Intelligence and Robotics Program, National University of Singapore, Sri MC Chauhan ji, Chair, IT, Delhi Local Network, Professor K.M. Soni, Deputy Dean, Engineering and Technology Domain, Amity University, Professor M.K. Pandey, Director, Amity School of Engineering and Technology, Head of Departments, faculty colleagues, participants, invitees, and most dear students. With immense pleasure, I welcome you all in the inaugural session of RDCAPE 2025. In this beautiful hall, we are not just inaugurating the international conference, but it's the starting and celebration of the spirit of the collaboration, research, meaningful research for the new and sustainable world. This, at the very outset, I would like to extend my humble gratitude to our founder, President Sir, for his visionary guidance and blessings. A very warm welcome and sincere thanks to all the esteemed guests. We are truly grateful for your support and gracious presence. Let us all extend a warm round of applause for our founder, President Sir, as well as the distinguished guests who have occupied the chair. It gives me a great pride to say that RDCAP was conceptualized in 2012 with the view to create a platform where we can share the deliberate and share the challenges and the solution for the electrical engineering domain. The first inaugural edition of this conference was held in 2013. And then from 2015 onwards, this conference was flourishing at an international level with a great sense of appreciation. The broader theme of this conference, Power, Control and Automation Engineering, is playing a very significant role in our daily life, as well as it's have a critical role in the national development, energy efficiency, and the sustainable infrastructure development. When India gained its independence, the Indian power sector started with just 1300 of megawatt of installed capacity, without any renewable energy component, and no national grid was there. But in last 7 to 8 decades, we have reached to the 490 gigawatt of installed capacity with 8 lakh circuit kilometer of robust transmission network. More than 275 millions of the consumers are connected through a one national grid. So this all has been happened because of the collaborative work by all the stakeholders, academia, research, and the government support. Similarly, likewise, if we see the control and automation happenings, we can recall some successful event that has been happened recently. That is the safe landing of the Chandrayaan-3, the precise operation of Sindoor to dismantle the terror infrastructure, surge in the factory automation, and our annual production growth due to the integration of control and automation technology with the AI and robotics. Such all remarkable progresses can be happening only with the synergy between the academia, industry, and government. I am pleased to say that the Department of Electrical and Electronics Engineering is making also a significant contribution to research and innovation related to the conference broader theme and actively engaged in doing research related to the grid integration issues, formulating control problem for the electrical and mechanical engineering, working on power electronics control issues, and many more. Our faculty have published over 500 high-quality research papers and over 50 patents have been filed till date. We are equally proud of our strong alumni network with many hundred graduates currently serving as technocrats and leaders in the corporate world. As our country look ahead for Viksit Bharat mission, we have some of the target very close to the RDCAP theme. That is what 500 gigawatt of renewable energy capacity by 2030, 1800 gigawatt of renewable energy capacity by 2047, which is aligned with the decarbonization goal, which is the part of sustainable world. Promoting integration of green hydrogen, battery storage, and smart grid, indigenous development of defense system, including the Sudarshan Chakra, which is a multi-tiered control system, the vision of our Honorable Prime Minister, sir, establishing India as a global leader in the robotics and AI. I am pleased to mention that in line with the national priorities, RDCAP 2025 has focused on three key themes: advancement in the power electronics and control technology, innovation in power system design and sustainability, and the intelligent computational technology application. Under these themes, our aim is to deliberate issue of improving power conversion, efficiency and control, supporting applications like renewable energy. In coming 2 days, we have planned 10 technical sessions where 75 papers will be presented and 14 distinguished invited talks will be happening where the eminent professor will be joining across the world to deliver the presentation and the key areas which is linked with the conference theme. I warmly invite each one of you to actively participate, share ideas, and forge new collaboration during this conference. On behalf of entire RDCAP 2025 organizing team, I extend our heartfelt gratitude to all the contributors, attendees, and honored guests. May this conference be academically enriching, impactful, and truly memorable. Thank you once again for your presence.
Thank you, sir, for beautifully presenting the essence of this conference. To take the session ahead, I call upon Professor Dr. K.M. Soni, Deputy Dean, Engineering and Technology, AUUP Noida, and co-patron RDCAP 2025 to share a few words with us. Please, sir.
Thank you, Dr. Anjali. A very good morning to all of you. Dear students, very good morning to you. Yeah, it's better. Persons on the dais, eminent speakers, delegates from academia and industries, HOIs, HODs, colleague faculty members, and most importantly, my dear students, to you attending in the hall, this auditorium, or online. On behalf of our most respected founder, President Dr. Sukke Chauhan, visionary and dynamic Chancellor, Dr. Atul Chauhan, Honorable Vice Chancellor, Dr. Balendra Shukla Madam, and the domain of engineering and technology, I welcome you all to this inaugural session of the 6th International Conference of Recent Development and Control, Automation and Power Engineering RDCAP 2025. It's my privilege to welcome the guest of honors, Sri MC Chauhan, Chair Delhi Local Network, IET, UK. We have long association with IET. We have programs accredited with IET. Dr. Prahlad Bedakapat, Deputy Director, Robotics and Machine Intelligence, BEng Program, National University of Singapore. Professor Dr. Mohammad Rehan, Director General, National Institute of Solar Energy, Ministry of New and Renewable Energy, New Delhi. We have long association with him through IEEE and otherwise. Dr. Cecil Kumar Vadu, Senior Professor, University of Murattuba, Sri Lanka. Dr. Dalu Silvamurthy, President STIF and Director General EDSI and Chancellor, Amity University, Chhattisgarh. Professor Dr. Balendra Shukla, Vice Chancellor, AUP, Professor Entrepreneurship and Leadership in IT, Senior Vice President, RBF, and Patron, RDCAP 2025. Ladies and gentlemen, with the blessings of our most respected and beloved Founder President, Dr. Sukke Chauhan, sir, and the guidance of our Chancellor and President, RBF, Dr. Atul Chauhan, sir, we Amitians are feeling proud that Amity University, in short history of just 20 years, has won a deserved place among the top universities in India and abroad with 200,000 students, 9,000 faculty members, and 12 state universities, and 18 campuses in India and about 20 campuses abroad. We have more than 500,000 alumni across the globe. AUP has received good rankings, many accreditations at the institute and program levels. In the fast-moving world of rapid technology changes, reputed international conferences are a significant platform to acquire knowledge and establish strong tie-ups with reputed experts in diverse fields and collaborate for mutual benefit. About ENT domain, having 6,000 students, 300 faculty members, offering programs in core branches of engineering such as computer science, IT, mechanical, EC, EEE, as well as specialized areas like renewable energy, AI, data system, VLSI, aerospace, aeronautical, defense, nuclear science, automobile, electrical vehicle, to name a few, at UG, PG, and PhD levels. Students and faculty members are doing research in cutting-edge technologies in all areas of engineering and advanced areas of engineering, includes smart grid, IoT, advanced control systems, blockchain, etc. We all know this type of conference always promote research and innovation and technical ideas amongst all researchers, faculties and students to enrich their knowledge much beyond the academic curriculum of the programs. The outcome of the RDCAP 2025 can make participants capable enough to step ahead in their own research projects and to transform their ideas into modern technologies related to their interests. This conference is a great opportunity to learn and to explore the opportunities to network with senior academic leaders of reputed higher education institutions and leaders from reputed industries globally. I am sure this conference will be enriching and add value to bring meaningful positive changes and surely lead to fruitful collaborative research and academic cooperation. I would like to express my sincere thanks to all resource persons, speakers who are going to conduct their sessions, and to paper presenters who are going to present their research findings in the next 2 days. I would like to congratulate Dr. M.K. Pandey, Dr. P.M. Tiwari, and the entire team of RDCAP 2025 for carrying the legacy of this conference forward and doing great job. Once again, I welcome you all to all. Thank you.
Thank you, sir, for your insightful and encouraging words. A true leader is one who knows the way, goes the way, and shows the way. It is my honor to welcome Professor Dr. Balvinder Shukla, Vice Chancellor, Amity University, Uttar Pradesh, Noida, Professor Entrepreneurship, Leadership, and IT, Senior Vice President, RBF, and Patron RDCAP 2025, without whose guidance this conference would not have been possible. An outstanding administrator, a brilliant academician, a vivid researcher, and a far-sighted visionary. Professor Dr. Balvinder Shukla is popularly known for her multifaceted insights, humility, and leadership skills. With this brief introduction, please welcome Professor Dr. Balvinder Shukla, ma'am, Honorable Vice Chancellor AUUP, to please address the gathering.
Our most respected Honorable Founder President, sir, Honorable Chancellor, our guest of honor, Dr. Prahlad Vedakar, Deputy Director, Robotics and Machine Intelligence, National University of Singapore, our esteemed guest of honor, Professor Muhammad Rehan, Director General, National Institute of Solar Energy, Ministry of New and Renewable Energy, esteemed guest of honor, Shri Moolchand Chauhan, Chair, Delhi Local Network, Institution of Engineers and Technology, and our guest of honor, Dr. Cecil Kumara Varu, Senior Professor, University of Muratubur, Sri Lanka, and my esteemed colleagues, Dr. Ramurthy, Dr. Manoj Pandey, Dr. Soni, and Dr. P.M. Tumari, all the distinguished guests, participants, speakers, and most important, future engineers. First of all, I extend a very warm welcome to all the esteemed guests on the dais, participants, and the researchers who are part of the 6th International Conference on Recent Developments in Control, Automation, and Power Engineering conference being organized by the Amity School of Engineering and Technology. I think this conference year after year has becoming very important as the dream of Viksit Bharat 2047 is that is for all of us, and academic institution, research institution need to do the task at the multiple level. First, creating the talent who will be contributing to the economic development by bringing the innovative solutions, and folks and the faculty members focusing on research and innovation aligned with the national priorities in this area. And it's not the time when the academic institutions can just work on their own. It is the era where the collaborations are very important, and I was so happy to see that organization like National Institute of Solar Energy, institution like Institution of Engineering and Technology, the robotics and machine intelligence, so the National University of Singapore or the University of Moratuba are part of this conference. So it's not the conference will just end with the presentations and the discussion, but this conference will lead to the further collaborations, that how we can work together in collaborative manner through the student exchange, joint research, joint publications. And the most important is that by the time we meet again the next year, and it always becomes important what have we achieved during the last 1 year since we had the last conference. And I can see the in last five conferences, and this is the sixth one, that how the many times the same universities representative are being the part of this conference. And this shows that this conference gives a lot of value to the participants, the people who are associated. And this year, I think it's a very special year because we need to focus more on how we promote the collaborative research. Recently, when the rankings of the university by Honorable Minister for the Higher Education was announced, and this is one of the things which was very important. With Honorable Minister have said that what the higher education institutions produce, and they said that's not the placement alone will contribute to the economic development. It's the how the student startup come from the higher education, and especially when there are so many areas of opportunities are there for the starting the new ventures, doing the innovations, bringing the products in this very hall. We had about 2 weeks back the conference on the quantum computing, and where the chairman of the the board of quantum mission, Ajay Chaudhary, said that today the India does not need the startups based on the apps. Rather, the India is looking for the product base, the startups. And I think that when we are talking about the especially the control automation or the power engineering, and I think the product based startups can very easily come. It's only that the how you are as a student, how you are choosing your projects, what kind of the innovation you do, and rather than looking for the placement, because the university has a very strong support system for the student startups, right from the ESL at the institution level, then the Amity Innovation and Design Center, then the Amity Innovation Incubator. They all are there to support the students if they have the ideas, if they have the innovative design or something. Recently, our students from Amity University, they have won the Google Prize for designing a product which will help the people on the roads from the fatigue. So therefore, the lot of opportunities are there, and I think the fertile mind of the students, innovative mind of the students, under the guidance of their faculty, and they can come with the new designs, new products, and because we have been seeing from, especially from the Amity School of Engineering and Technology, students when they display their projects in the final semester, lot of innovative designs we see, and I'm sure that this is again this particular batch, the final year, and the pre-final year will be coming with the innovative designs, the products, and which will be translated into the student startups. With respect to the faculty's research, Dr. Soni, Dr. Pandey has emphasized all, and I think that without research, I think the teaching cannot be improved. So therefore, I'm so happy that our faculty um, of the Amity School of Engineering is focusing on big way research, which directly goes to the quality of teaching, the quality of student development, and ultimately into the students' progression. And I think that recently our Corporate Source Center of Amity School of Engineering and Technology is doing the big hackathon, the Riverthon, and because again that is very linked that how you can come up with the innovative solutions. And I think the hackathons has become now the way of life to develop the requisite competencies and skills in the students for the problem solving as well as coming with the innovative solutions. So, because our honorable chances vision is that how the youth of nation, youth of Amity comes with the solutions, the technology, the innovations, which are not only contributing to the economic development of the nation, translating it into the Viksit Bharat, but also contributing to the world to make the world a better place to live. And therefore, the last year when our honorable chancellor announced the it will be always the focus on the student's success, on the student's happiness, and the same thing was emphasized this year again by honorable chancellor on the day of inauguration of Sangathan. So I request all the students, that what the honorable chancellor is envisioning for you people. I have expectation from all of you. I'm sure this conference is going to give you a lot of input because I can see the profile of the speakers, the topics of the various sessions, and I think each one of you will have many things to learn and come up with the innovative ideas which will directly contribute to the economic development of nation. With this, once again, I thank our esteemed guest on the dais, Shri Moolchand Chauhanji, the chair of Delhi Local Network, as well Professor Mohammad Rehan, Director General of National Institute of Solar Energy. And while I was sitting there, and I said that three of us who belong to also the IET Delhi chapter, and we are sitting. So I think IET Delhi chapter has a lot of presence at in this conference, and also this time the IIT Delhi chapter is a partner to this conference also. So many thanks to Delhi chapter being the partner of this conference. I always emphasize that IET should organize the events, the activities at the campus for the benefit of the students, which will also promote the membership of the students of the IET. And Amity has been always very big support to the IET, and I'm sure the student get the benefit of being the member of the IET. With this, once again, I extend very warm welcome and wish the grand success of RDCAP 2025. Thank you very much.
Thank you, ma'am, for your insightful address, inspiring leadership and vision. Science is the great adventure of the human spirit, forever pushing boundaries. I now request Professor Dr. W. Silvamurthy, President, Amity Science, Technology and Innovation Foundation, Director General, Amity Directorate of Science and Innovation, Chancellor, Amity University, Chhattisgarh, India, to please share his words of wisdom.
Friends, very good morning to every one of you. Honorable Founder President Dr. Ashok Chauhan ji, who gives directions for all the research innovation in the whole Amity Education Group, who has created this whole Amity universe, as was mentioned, with 12 universities in India, 18 campuses abroad, 28 schools, 250,000 students, 250,000 students, 10,000 faculties, 5,000 PhD scholars. So Amity has really become a big universe with 8 lakh alumni across the globe. See the force of Amity. This is by Dr. Ashok Chauhan. Let's give a big clap to the founder, the visionary, who has created this whole Amity universe today, which is growing. The latest university is in Telangana, Hyderabad, which is in the Aero City of Hyderabad. The previous one was at Bangalore, so we are growing. And it will grow further. And founder president vision is every state must have one Amity University. And then 18 campuses abroad like Dubai, Mauritius, Singapore, London, USA. It should become 50 campuses. This all should happen in 1 decade. So that's the target which he has given. So the whole system is gearing up, moving towards that vision. And then he has given a focus on research and innovation as the fulcrum in the whole educational system, right from curriculum design, pedagogy, method of delivery, learning by doing. So this is what is the USP of our Amity education. And also we don't look at you people as the students, community. We consider you as the future global citizens. So we give you not just only your domain knowledge, material subject knowledge, but then we give you the overall learning of life in this educational system, which is knowledge, including spiritual knowledge, skills, including soft skills, good behavior, sanskars, values, resilience to face challenges in life. This is what Amity gives. So let's give a big clap to our students and the alumni who will also be joining at this event. Some of the alumni have been invited for this conference. So I must appreciate the Chancellor, Dr. Atul Chauhan, who is now in Middle East in one of the program, along with the Minister of Commerce in our Amity University, Dubai. And he has conveyed his greetings to you. And so let me convey Dr. Atul Chauhan, the Chancellor's greetings to all of you. My appreciation to Professor M.K. Pandey, who is the Director of Amity School of Engineering and Technology, and who is looking after almost more than 6,000 students in all the disciplines of engineering. So that is asset, Amity School of Engineering and Technology, and who is also one of the main architects guiding this whole program today. And also our Professor P.M. Tiwari, head of the EEE, that is Electrical, Electronics, Engineering, and which is ably guiding. And this is the 6th edition of the international conference he is holding on this theme, control, automation, as well as power engineering. And along with his team, Sina, and all the team members of ASSET, compliments to you, including Dr. Soni, who is the Deputy Dean of our Engineering and Technology. So you have done a great job to bring all great minds together, the luminaries who are sitting on the dais, off the dais, and also who will be joining us and who have joined us online. So it's great compliments to each and every one of you. And we are fortunate to have very distinguished guests of honor who is sitting on the dais. I'll start with Sri Moolchand Chauhanji. And his IET is very important, Institution of Engineering and Technology, UK. And there is a Delhi network chapter, which he is spearheading as the chief of this. Dr. Sri Moolchand ji, welcome to Amity. And also we will work with you on IET with many more programs, as was mentioned by Vice Chancellor. We are also fortunate to have DG, National Institute of Solar Energy, our Professor Mohammed Rehan. I met him just a week ago in that MNRE conference, which was held just a week ago, where they were looking at hydrogen as a fuel. Where do we stand in national green hydrogen mission? Where do we have to reach? How do we reach? So we deliberated. So we were very fortunate to hear his vision in the inaugural, and also he was looking at how do we integrate solar energy with hydrogen, because if you have to create green hydrogen, the power can be from solar, which is green. So that is what is the focus, where the country has already reached through the National Solar Mission. Big targets have been achieved, and we are moving towards the carbon neutral by 2070, and in which Mohammed Rehan is playing a very important role. Let's welcome DG of this National Institute of Solar Energy. And we are privileged to have Dr. Prahlad from Kerala. We are proud to have him close to our from Kerala, and he is now with the National University of Singapore. And we were looking at how do we collaborate with him, because he is looking at robotics and automation, robotics, and he is looking at the humanoid robots and many, many important areas which is relevant to the theme. And he is making a significant path-breaking contributions in this domain. Welcome, Dr. Prahlad. And also we are fortunate to have Dr. Cecil Kumaravade from Sri Lanka, and he is sitting over there, and he is also a guest of honor. And he is also working in how we bring artificial intelligence and power engineering and power grid management, predictive maintenance of the grids, and so many areas in which he is looking at the artificial intelligence. So such great leaders are here to deliberate on the theme of the conference, which is very important in terms of the Industry 4.0, which India is emerging as a hub of manufacturing. In terms of, if you look at the GDP contribution from manufacturing sector is growing up in every domain. And so here, this conference is very important because you are looking at the power system, that is power engineering, and also you are looking at automation, which will increase the productivity and the production. And also we are looking at the controls, which is necessary in all this manufacturing. So as the vision of our country is very clear, Honorable Prime Minister Shri Narendra Modi ji has given a clear vision for the country that by 2047, which is not very far, just 22 years from now, India should have become a developed nation. Developed nation in all domains, self-reliance, Atmanirbhar Bharat. So in all this, we are looking towards every aspect. And so this conference deliberation becomes very important in terms of control, automation, and power system. And Industry 4.0, now we are talking about Industry 5.0. There again, all the three facets are going to play a very, very important role. Whenever you are talking about make in India and make for the world, so that is the slogan with which India is now looking at how do we make things, design, develop, evaluate, certify, manufacture, scale up, and then also give it to the world. So that is what is make in India and make for the world. So this is being given a big push again. So these three facets are going to play a very important role. Whenever I talk of control, being a person from DRDO, Defense Research and Development Organization, where I served for 40 years, and I was DG for 10 years. So we were looking at missiles, the Agni, Prithvi, Akash, Nag, Trishul, BrahMos, interceptor missile. Now we are talking about also the BMD, ballistic missile defense, which is very important for the country today. So in which control plays a very, very important role for the missile. Otherwise, it will go elsewhere. So you need control, guidance, navigation, all this very important, which you are going to deliberate. Similar thing is applicable also to space mission. Amity is having a Amity space mission in which we are also contributing to the health monitoring of the spacecraft as it flies. So using the artificial intelligence. So he was also talking about health of the power engineering. So we are looking at health of the spacecrafts, Amity University. So in space, also the control is very important. How do you navigate? and control the movement of the spacecraft to the right trajectory, the orbit, and then how do you position the satellites, and also the control of the satellites in orbit. So all these are very vital. So control is playing a very important role, not only in manufacturing, but also in defense as well as in the space sector. And then the power system, we are now focusing on electrical vehicle. So in this, we are talking about two-way connections, that is grid to power, grid to the vehicle, and then vehicle to the grid. That is the new concept in which the dual direction of the grid management we are looking at. SCADA is going to be discussed today. So I won't take much time to, and then conclude saying that Amity today have filed 2,600 patents. So let's give a big clap to all the scientists, faculties, 2,600 patents. And then we have published 45,000 research papers. Our H index is 189. And we have transferred 35 technologies to the industry. So this is Amity, research and innovation. So the final message, carry home message, I would like to give it to the participants. India has always valued Vasudeva Kudumbakam. We are a global village. All of us, whether it is from Sri Lanka or from UK or from any country, we are all one. We are in different places with no boundaries. And so this is what is the concept Vasudeva Kudumbakam. So let's work together. Let us integrate ourselves together for the good of the humanity. Let's create a healthy, peaceful, prosperous, harmonious, and also happy world. So that is what is the final message. So I will eagerly look forward to the outcome of the deliberations with specific recommendations. It should not be yet another conference, but it should be a productivity-oriented, outcome-oriented conference. So we will be eagerly looking forward to the outcome in the form of specific recommendations, which we would implement not only in Amity, with you all, that we will see that its implementation not only at the national level, at the global level. Best wishes. Thank you so much.
Thank you, sir, for your inspiring and futuristic thoughts. We are honored to welcome Dr. Cecil Kumar Vadu, Senior Professor of Electrical Engineering at University of Moratuwa, Sri Lanka. He is also a distinguished professor at Shanghai University of Electric Power with extensive contribution in power system and electrical engineering research. With this brief introduction, I request sir to please address the gathering.
Founder, President, sir, respected Chancellor, we have Chancellor, sir, from Chandigarh, directors, deans of the faculties, distinguished faculty members, eminent speakers, dear participants, ladies and gentlemen. It's a great honor to stand before you this morning. This inauguration of the 6th International Conference, recent developments in control, automation, power engineering. Vice Chancellor Sir spoke in detail about the importance of these areas. Thank you, Amity University. The numbers mentioned outside this world, 5,000 PhD students, 2,500 patents. There are no words to explain those achievements. I'm pretty sure this conference is arriving at a time we are dealing with, as a global community, the issues of the twin challenges, climate change. You can see the climate change is real. It's happening in human time scale. Every year we see it is happening. So there's a huge role as engineers and technologists to play in that regard as part of a global community. And the digital transformation. Digital transformation requires a huge amount of power. It's data centers, artificial intelligence. We're talking about gigawatts of power requirements. And in my own work at the University of Moratuwa, over the years, my team, I have focused on artificial intelligence applications, particularly electrical engineering, power engineering, and energy systems, and health monitoring of the machines, renewable energy plants. So our flagship work, hope to talk about in my keynote speech is non-intrusive load monitoring, how to monitor the energy performance of the households without using intrusive sensors, completely sitting outside the building and the metering point. So energy conservation, efficiency, extremely important. Now, I take this opportunity to request the young people of Amity University. We have wonderful young students like Aryan. Aryan's second year electronics engineering students taking care of us, just like a son taking care of his own parents. The future belongs to these young people. And every light bulb that's burning, that's shining without purpose, every electric fan that's running without a purpose contribute to climate change. So I with me, the students, we will stop using the elevator up to level 4. We will walk. We will not request the elevator to come all the way from the 6th floor to the 2nd floor because we want to travel from the 2nd floor to the 1st floor. And the elevator drops us off at the 1st floor and goes back to the 6th floor to pick up somebody else. Is that fair? It's not fair. So we will not use the elevators in the Amit campus. Who's with me? Excellent. We will walk. We'll use the stairways. So I think the importance of the collaboration, the Vice Chancellor highlighted. So people with diverse backgrounds, diverse, thinking patterns coming together to collaborate, and we travel, we share, we experience different cultural backgrounds, and that makes collaboration doubly rewarding. So I believe now the technology, the research and advancements to be focused, we hope, on solving global issues like climate change, and giving more and more education training opportunities for the underprivileged communities. The technology can make a huge difference in every sector: health, education, energy, and so forth. I'm quite sure, looking at the conference program, the number of papers that will be presented and the keynote speeches, and everyone will go back home with more knowledge and, most importantly, more connections. The connections, the networking is extremely important in professional practice and development. So I wish all of you a wonderful experience in these couple of days. And one more time, I would say we feel very honored and privileged to be here with you, taking part in this conference. All the very best. Thank you very much.
Thank you, sir, for your address. We are honored to welcome Dr. Prahalad Wadekepad, Associate Professor at National University of Singapore and a pioneer in robotics and artificial intelligence. He is the Founder Secretary and long-serving General Secretary of Federation of International Robot Soccer Association, Editor-in-Chief of Springer Handbook of Humanoid Robotics, and a leader in frugal innovation and AI research. Sir, we welcome you here and are looking forward to gain insightful address from you.
Namaste and good morning. In 1987, in IIT Madras, I started with fuzzy logic and later PhD in neurofuzzy systems. That was the explainable AI as early as 1980s. 1996, I moved to South Korea, started with robots playing football, where reinforcement learning was used. Multi-robotic systems, multi-agent systems, agentic AI was there. The robots have bodies. The embodiment was there. So all these things were there for a long time in the research community. But now with ChatGPT, everybody across the world is aware of AI. Where do we place ourselves when ChatGPT is there with every one of you? Do you get help from ChatGPT? Do you look down on yourself that you don't know what ChatGPT is giving you? I would like to say, ChatGPT doesn't have to worry about the chemicals and the neurons in your body. It doesn't have to worry about the sociality of complexities associated with the sociality of human being or being a human. The day we are conceived in our mother's womb, till we leave this space, the most complex biological system of the human body is controlled by our head. That's the most difficult thing to do. I worked in two-legged humanoid robots. In the known universe, that's the most difficult thing to do. We can walk on two legs. I can dance. I can fall in love. I can hug you. I can do all those things that we are capable of doing. That's the beauty of our brain. Never look down on that based on the marks you get. Marks is nothing to, examinations are nothing to really evaluate the human brain. Unfortunately, we are not meant to write exams. Our brains are not. We are not meant to do repetitive tasks. We are not meant to sit on a chair. We are meant to run, climb trees, and swim. Unfortunately, we moved away from that and we have mental wellness issues. Talk to your parents every day. Spend 1 hour. Talk to your friends every day. Make the world great for you. Money will come and go. And fame will be there. How long? It doesn't matter. During COVID, I was alone. My family was in India. Nothing helped me. My publications, nothing helped me. No accolades, nobody else. It's a human connection that helped me. And I would like to say, do well for your body first. Then the head, the heart ahead of the head. All the best to you. Thank you for inviting for this conference. Thank you later.
Thank you so much, sir. We are honored to welcome Dr. Mohammad Rihan, Director General of National Institute of Solar Energy.
Let's welcome our Honorable Founder President, Dr. Ashok Chauhan ji, who has just joined. Welcome, Founder President.
Thank you, sir. Thank you. Thank you.
Founder President, he has so much responsibilities, but for him, research and innovation is the highest priority. He has come all the way to bless you all children and also to our faculties and the guests, particularly he has come to greet the guests. Thank you, Founder President, for finding time to be with us and give your blessings to all of us.
Please continue.
We are honored to welcome Dr. Mohammad Rihan, Director General of National Institute of Solar Energy under the Ministry of New and Renewable Energy, Government of India. He has led pioneering work in solar energy, smart grids, and green hydrogen. Dr. Rihan is the author of influential books on green energy and has guided PhD scholars who secured the prestigious Prime Minister's Research Fellowship and spearheaded the integration of 6.5 megawatt power solar PV plant at AMU. With this brief introduction, I request Sir to please address the gathering.
Founder President, all the esteemed members on the dais and off the dais, faculty members, delegates of the conference, students, a very good morning to all of you. First of all, I am very happy to join this morning, all of you. There are various reasons behind that. So one is, it is always a pleasure coming to MET University. And very rightly said by presidents of MET Universe. It is a universe actually. So it is always a pleasure coming to MET Universe, any component of any MET Universe. The sort of vibrancy, the sort of dedication from the leadership, from the faculty members, the enthusiastic students, it is always good to see and good to interact. Second reason is this conference, RDCPAE. This is 6th edition of this conference, and it has made a mark in the community. I have seen it in different forms, from sometimes from IEEE point of view, sometimes from as a contributor, and sometimes as a speaker. So I have seen that they have maintained a standard, and that is why this conference has made a name for it. And it is among very few conferences dedicated to power engineering. Among a huge number of conferences on IT and related issues, you see very few conferences dedicated to electrical engineering or power engineering. So, and as somebody said that actually we say that this is a digital world, IT driven world, but the whole IT revolution is driven by electricity. So the IT sector has to take care of electricity also, because this is the oxygen of your system. And as someone says that it is only in the engineering colleges where IT is driving electrical engineering department. In the real world, it is the other way around. And so I appreciate the efforts of Professor P.M. Tiwari, who has been the guiding force behind this conference since first edition, and it is a good contribution to electrical engineering. Now I'll make three points. One point is related to some national developments. One point will be an appeal to the faculty, and one last point will be related to students. So we hear a lot about climate change, need for sustainable development, global warming. And I hope you understand, and my previous speakers have highlighted this also, that your electricity choices have a direct connection with global warming. Electricity generation by conventional methods has been a major source of global CO2 emissions, and that is the major cause behind global warming. So that is why we want to shift the whole system from coal-dominated system to something which is dominated by solar, wind, hydro, and other sources. And the contribution, the initiatives of our country are remarkable in this field. And I especially urge our students to please be aware of what is happening, what has been done, and where we are heading to. You will feel proud of the way we have, in a short span of time, we have transitioned from a coal-dominated electricity system to a system where renewable energy sources now contribute more than 50% of the installed capacity. You know, we had under the Prime Minister's Panchamrit targets, we had set a target that by 2030, we will have 50% of renewable energy sources in the country out of the total installed capacity. And we have achieved that target before 5 years earlier than the set target. And maybe you have missed a very important century few months back. We have crossed the 100 gigawatt mark in solar energy. And right now we are standing at 120 gigawatt of solar energy in the country. We had 10 megawatt in 2011. From 10 megawatt in 2011 to 120,000 megawatt right now, and somewhere around 280,000 megawatt by 2030. So the whole electrical engineering or power grid is going through a rapid transformation. This is important not only from the environmental point of view, but it is important from energy independence point of view. As I have mentioned, you understand the importance of electricity. If you don't have reliable electricity supply for a few hours, the whole world stops actually. So we cannot be dependent on such a crucial thing on completely on imports. So fossil fuel based economy was mostly driven by imports. So it is giving us energy independence. Then a very important part is solar energy is highly decentralized in nature. You can install it anywhere. So where you cannot ensure grid access, you can ensure supply through solar energy systems because it can be a distributed system. So it is environment friendly, energy independence, energy access to all. So this is how we are making contribution to the national sustainable development goals, to the international sustainable development goals. And I urge all the young engineers, all faculty members to see there are so many opportunities for all of you to look for the problems and start working on this. Now, because it is a conference and we are presenting R&D initiatives and results and all, I have an observation that there is a shift in the R&D expectations. For a long time, the R&D quality or the contributions we were judging by the numbers. Somebody has so many publications in SCI journals. Somebody has so many citations. So that means he is a good researcher. He is doing some great contributions. So I personally feel there is a shift now. A shift in the sense that the shift towards what is the impact of your work. Are you creating any impact? Is it changing anything? Are you addressing any real world problem? Is your research is related to something which society needs? So I see this is a change. And I think Vice Chancellor talked about the startup initiatives. So startup is actually an outcome or byproduct of this shift. We are looking for how your research is actually creating some change, leading to some change. And I always say that we have to target, our research should be of global standards, but mindful of the local needs, what the society needs, what my country needs. So that has to be done. Third point I wanted to address specifically the students actually. As we are talking about research. So research is a very intense work. It requires deep thinking, critical analysis, analytical capabilities. And these capabilities can only be developed if you learn to work. If you learn to work, I conclude. So if I am here, so let me complete at least 5-7 minutes should be given. So we have to learn to work in a, can I analyze something? Can I give 2 hours of dedicated work? And this is a major challenge because of the all-time notification world which we are living in. So, see, 15-20 years back, the most important challenge for a research work was literature survey. Can I find related literature to my problem? Now, that is not a challenge. For any topic, you just write few phrases on Google and you will get heaps of information. The thing is, can you extract the useful things from that? So that capability has to be developed. And people say that reels are not good actually. But I see there is a lesson from that. Can I communicate something in a minute, in a video of 1 minute or 2 minutes? That's a very important capability. So, and so, a very popular writer has written that if I had more time, I would have written shorter articles. So you need a higher level of skill in writing in a concise way or speaking in a concise way. And I have seen this in this schedule also. Earlier we used to have 15 minutes slot for a speaker, then 10 minutes. Now they have come to 8 minutes. So this is again a good innovation. So with this, I think because of time constraints, I'll conclude now. So I'll reiterate 3 points which I have said. One is please learn, understand how the national energy landscape is changing, and there are so many opportunities for all of you. One thing. Second thing is research and development is more towards now how it is impacting the social needs, the local needs and all. And third is, can we develop some deep work capabilities where we can concentrate, analyze the heaps of information which is available. With this, I thank the organizers and I wish all the success to the conference.
Thank you so much for your enlightening words, sir. We are delighted to welcome Shri Moolchand Chauhan, Chair of Delhi Local Network of the Institution of Engineers and Technology UK and former General Manager of North Central Railways, a distinguished leader in India railway sector. He has contributed extensively to advancing rail infrastructure, operations and innovation. His leadership and dedication continue to inspire professionals across engineering and technology communities. With this brief introduction, I request you, sir, to please address the gathering.
Good morning, everyone. Honorable Founder President Dr. Ashok Chauhan, under dynamic leader of President Dr. Ashok Chauhan, Amity University is achieving greater heights every year in innovations, research, and startups. All dignitaries on the dais, delegates, speakers, ladies and gentlemen. At the outset, I would like to express my thanks to Dr. Balwinder Shukla and organizers of this 2 days conference who have given me opportunity to address in the inaugural session. It is truly an honor to speak on the topic recent developments in control, automation, and power engineering. These 3 areas form the backbone of modern industrial growth and technological progress. Today, they are not only driving efficiency, but also shaping the future of sustainable development and smart living. Over the years, control engineering has moved from simple manual regulation to highly advanced intelligent systems. Modern control systems are now deeply integrated with artificial intelligence and machine learning. Predictive control, adaptive control, and robust control techniques are allowing industries to achieve higher precision and efficiency. In manufacturing, automated control loops can now self-adjust based on real-time data, reducing downtime and improving quality. In robotics, AI-driven control systems provide unmatched safety, speed, and accuracy. Now, we'll look at automation. Automation is no longer just about replacing human effort. It's about enhancing productivity and enabling human-machine collaboration. We are now in the era of Industry 4.0. Industrial automation is now driven by IT/OT, convergence, and interoperability. This means smart factories with Internet of Things, where machines communicate with each other, share data, and optimize process without human intervention. Robotics, sensors, and cloud computing are creating production lines that are faster, safer, and cost effective. No automation system is complete without security. Cyber security by design is essential. It provides a life cycle framework from defining component level security requirements to system level risk assessment and defense in-depth plans. Finally, we talk about power engineering. The world is currently facing an energy challenge and power engineering is evolving to meet it. Earlier, my predecessors have already mentioned about renewable energy sources. These sources such as solar, wind and hydro are being integrated into power grids with the help of advanced control and automation. The rise of smart grids is one of the most significant developments. Smart grids ensure real-time monitoring, load balancing, and efficient power distribution. They also allow consumers to manage their own energy usage through smart meters. Another exciting development is the progress in energy storage systems, especially lithium-ion and solid-state batteries, which are crucial for electric vehicles and renewable energy integration. Additionally, microgrids and distributed generation are empowering remote communities with reliable and clean power. What makes these fields truly exciting is their convergence. Control systems, automation, and power engineering are no longer isolated areas. They work together. For example, in renewable energy plants, automation ensures efficient operation, control systems regulate power flow, and power engineering enables reliable transmission. Together, they are helping us achieve sustainability, reduce carbon emissions, and build a greener future. To summarize, the recent developments in these fields can be highlighted in 4 key points: smart and AI driven control systems, more accurate, predictive, improved safety and adaptive, Industry 4.0 and automation, intelligent factories, robotics, IoT, and cloud driven technology. Advances in power engineering, smart grids, renewable integration, digital twin technology, advanced energy storage system, cyber security for grid infrastructure, digital substations, AI and machine learning in power management, grid forming inverters for ensuring stability and adoption of silicon carbide devices for higher efficiency in drives and converters. Convergence of disciplines working together for sustainable and efficient energy solutions. As we celebrate the progress in engineering, let us also remember that these innovations must be used responsibly. The ultimate goal of technology is not just profit or productivity, it is to improve human life and safeguard our planet for future generations. I am sure the deliberations being taken place in these 2 days conference will be very fruitful. I wish the grand success of this international conference. Thank you for being here.
Thank you, sir. Books and publications are the timeless footprints of human wisdom, and Conference Souvenir is the collective voice of researchers across the globe. It is not just a printed document, but a treasure of knowledge carrying with it the essence of new ideas, innovative solutions, and future pathways in the domain of control, automation, power engineering, artificial intelligence, renewable energy, and computational technology. With this great pride, I now request our esteemed dignitaries on the dais to kindly join together for the official release of RDCPAE 2025 souvenir. A huge round of applause for the release of souvenir. Thank you, respected dignitaries, for unveiling this knowledge repository. We sincerely hope this souvenir serve as a valuable resource for researchers, practitioners, and students and continue to fuel new innovations in the years ahead.
So thank you all with great humility now. And it's my proud privilege to invite our Honorable Founder President, sir, to extend his blessings for the success of this 2 days conference, recent development in control automation and power engineering. Honorable Founder President, sir, thank you very much for joining. May I request you to please extend your blessings to us. Honorable Founder President, sir. So let's have a huge round of applause. Please welcome our Honorable Founder President, sir, with this round of applause. Sir, thank you very much for sparing your time, sir.
मुझे बोलना है
Yes, sir. Please, sir.
पांडे जी, एक वाक्य चलता है पूरे कैंपस में, जब मनोज पांडे बुलाता है तो चौहान मना नहीं कर सकते. तो यू नो आई एम सो प्राउड. अभी मैं आपका प्रोग्राम देख रहा था एंड आई हर्ड द लर्नड प्रहलाद जी, डॉक्टर प्रहलाद, एवरी वर्ड वाज सो वैल्यूएबल. देन आई मोहम्मद रिहान जी को सुना, उनको कम टाइम दिया तो उनको और अच्छा बोलना था. अगली बार उनको 25 मिनट के लिए बुलाएंगे. फिर मूलचंद जी का सुना. तो आई थिंक बट आई विल लिसन लेटर ऑन कुमार वाडा जी, वो नहीं सुन पाया मैं. माय डियर स्टूडेंट्स, अभी 5 प्रोग्राम चल रहे हैं. तो एक बार मैं आपको घटना सुनाऊं. हार्वर्ड में एक प्रोफेसर बीटेक की क्लास में लेक्चर देके निकला 1 घंटे का. तो एक स्टूडेंट साथ आया कि सर आप एमटेक की क्लास पढ़ा रहे थे, ये तो बीटेक की है. तो मेरा भी यही हाल है कि 5 प्रोग्राम देख रहा हूँ. अगर मैं बट आई लिसन एवरीबॉडी. जिसको मैंने नहीं सुना, इसमें जैसे हमारे एक स्पीकर हैं, उनको मैं नहीं सुन पाया, उनको मैं कुमार वाडा जी. बट मनोज पांडे, आई एम रियली सरप्राइज्ड the way you have organized. I have read your whole program. Something great hard work, and I think these are the opportunities where my students learn from such dignitaries. Each word what the 3 speakers I have heard is something where is a lot of learning. In each word there is a learning. And my dear student, I think these are the opportunities to decode these successful persons, why they have become so successful, why they have risen so high, and try to follow each word of them, try to learn each from them about this conference. It is so important for you. In life, you will never forget what was told here, because I have tried in my whole life to learn from everybody and practice it. So one day, somebody was telling me today in the other program, Dr. Chauhan is working so long hours. What is the remedy? I told, it is very clear. When I see my students, my faculty member, my researcher in front of me, that is for me energy booster. I don't take any vitamin or something, but the energy which I get from you people, from my staff, from my researcher, from my HOIs, my vice chancellors was sitting here and there also. I think that energy is so unbound. So I congratulate my student and my real everybody faculty. I know most of you, the program which you have made is something great. And I think when you go out of it, you will have some new ideas. Try to follow an idea with full ambition and interest. Nobody can stop you. If you have a mission, एक मिशन है लाइफ में, तो कोई रोकने वाला नहीं है अगर आप उसमें डेटरेंस ना आने दो. तो यही मैं कहता हूँ. अभी सबने आप स्टूडेंट की भी तारीफ करी, रिसर्चर की तारीफ करी. उन्होंने, रिहान जी ने कहा मैं इसलिए मीटिंग में आता हूँ, यहाँ की एनर्जी है, यहाँ का एटमॉस्फेयर है, यहाँ का मैं वातावरण देखता हूँ. So, these comments from these people are because of my faculty member, researcher, staff. We are really doing wonders. When I see, अभी मैं 5 प्रोग्राम में बोल रहा हूँ, ये चौथा है. 5वां लखनऊ वाले वेट कर रहे हैं एग्री पोस्ट के. तो मैं इसलिए कह रहा हूँ कि you are studying in a institution which is going to be in 2047. Note it down. It can't be otherwise. No, in 2047 among the 5, 6, 7 top universities of the world: Harvard, Cambridge, Oxford, Yale, Wharton. And who will do it? You will do it. My students are spread all over the world. Asim ji would have also spoken today, Atul ji. Atulji has gone to Dubai because Piyush Goyalji is there for 2 days. Asimji is coming back. He's in the flight from New York because our Harrow School has opened the first batch and he was there. So we are spreading all over the world. So wherever you go, I was hearing one of my regional pro-vice chancellor, wherever you go in the world, you file a MBT. And Ajay Chauhan, they spoke in the lecture in the Sangathan. Wherever you go, there is a MBT. So to whose credit it goes? To my student. They spread the news that if you study in MIT, then just make a mission in your life. And if you don't achieve, I tell you, this is my failure. And I never like a failure. So I will not take, because Lucknow people are ringing my bell, ki sir, aapka bologe. So my blessings to all of them, Manoj Pandey ji, to you and your faculty member, you have contributed relentlessly for this. My blessings to them, and they are doing for the mission of the God. And we will really change the world. What is the slogan of my worthy Chancellor, Atul Chauhan ji, additional Pro-Vice Chancellor. And now yesterday, I heard in the Sangathan, or yesterday about Ajit Chauhan ji and Amol Chauhan ji. The next generation is developing to take care of further long years. So I think proud of all of you, all the best. Have a mission. What you have learned from them, make notes. I have made notes about there. I have learned a lot from them. And we should practice that, and then nobody can stop you in the world not to achieve your mission. Only you want to set a mission. Dr. Manoj Pandey, Vice Chancellor, you spoke very well. She's also jumping from one program to other program. Thank you very much. My blessings to all. So I have
Thank you very much. Thank you very much for your time, and we are really get motivated with your kind words. Dr. P.M. Tiwari is the main coordinator for this conference. He is head of the Department of Electrical Engineering, and his team, they really worked hard for this conference. So we need your blessings.
Very much. Tarif suni hui already. I know everybody. Very good.
So with this, can we have a standing ovation for our honorable founder? Because
अरे भाई क्यों परेशान करते हो? रामदेव जी कहेंगे योगा करते हो?
Because
पांडे में खड़ा
get
करता
motivated.
Thank you. Thank you. Very good.
Thank you very much, sir. Thank you.
So you want to slow down. Thank you.
Thank you, sir, for showering your blessings on all of us. As a token of our deep respect and appreciation, we now move to a very special part of the inaugural session, the felicitation of our esteemed dignitaries. At Amity University, it is our cherished tradition to honor our distinguished guests with a memento and a tulsi sapling, symbolizing warmth, gratitude, and reverence. May I now request the dignitaries to please come forward and felicitate our guests. I request Professor Dr. Silva Murthy sir, K.M. Soni sir, and Dr. P.M. Tiwari to please come forward for felicitating our guest. First, I request the dignitaries to please present a memento and a sapling to our guest of honor, Shri Moolchand Chauhan ji. A huge round of applause for sir. A huge round of applause for sir. Once again, I request the dignitaries to kindly present a memento and sapling to our next guest of honor, Professor Dr. Mohammad Rihan. Thank you, sir, for gracing this occasion with your esteemed presence. Once again, I request the dignitaries to please present a memento and sapling to our next guest of honor, Dr. Prahlad Vadekepat. A huge round of applause for sir. Thank you, sir, for sharing your valuable perspective with us. A huge round of applause for sir. Again, I request dignitaries to please present a memento and a shawl to our guest of honor, Dr. Cecil Kumaravadu. A huge round of applause for sir. With this, we extend our heartfelt gratitude to all our esteemed dignitaries. Your presence here today is not only an honor for us, but also a source of immense encouragement and inspiration for the entire Amity family. Thank you, everyone. Now, on behalf, okay, we can have a group photograph here. On behalf of Department of Electrical and Electronics Engineering and Organizing Committee of RDCPAE 2025, I deem it a great honor and privilege to extend a vote of thanks on this momentous occasion. First and foremost, I would like to express our deepest gratitude to our Honorable Founder President, Dr. Ashok K. Chauhan sir, and our Honorable Chancellor, Dr. Atul Chauhan sir, for their visionary leadership and blessings. My heartfelt thanks to our Chief Patron, Professor Dr. Balwinder Shukla, Vice Chancellor, Amity University, Uttar Pradesh, for her inspiring words and constant encouragement. Ma'am, your leadership is a true source of motivation for all of us. I extend our sincere gratitude to Professor Dr. W. Silva Murthy and our esteemed guest of honors. Your presence and enlightening words have added immense value to the conference and inspired our every participant. A special word of thanks to our distinguished guest, Ms. Kamya Khattar. I also take this opportunity to thank co-patron Professor Dr. K.M. Soni and Professor Dr. Manoj Kumar Pandey sir for supporting us always. My sincere thanks also goes to all the faculty colleagues, research scholars, student volunteers, technical team, Amity staff, who have worked tirelessly behind the scenes to ensure the seamless execution of this inaugural session. Finally, I thank each and every participant, academician, researchers, and delegates for your gracious presence. With this word, I once again thank you all and request the dignitaries and delegates to please proceed for high tea, after which we reassemble here again for the plenary session in I2 Moot Court. Thank you for your gracious presence. Thank you so much, sir. Thank you very much. Thank you. सर ये हम पैक कराते हैं ना सारा सामान आपका बैग
Thank you so much.
So folks, whether male or female, start cooking tomorrow. Cooking is the most important thing in life. Don't expect somebody else to cook for you, okay? So cooking, we are here because of the cooking. Of course, we had technological revolution in 1970s. But now, what is happening is AI. What Sundar Pichai says is very important. He says AI could have more profound implications for humanity than electricity or fire. And this is something we have to understand in the context. And I like Jean Piaget's point. What is intelligence? Most people consider that as reciting or memory is intelligence. Because our exams are like that, to check the memory. It's not intelligence. Intelligence is what you use when you don't know what to do. And many a times, since childhood till we leave this place, we have to use our intelligence. And I would like to say, irrespective of the age, irrespective of the knowledge gained through degrees, everybody is intelligent. And we have to respect that. So what happened? In 50s, AI came into existence, but AI died because AI was mostly on symbol manipulation. Symbols do not have derivatives. And without derivatives, you can't change parameters, you can't learn. And then came in 80s machine learning, where parameters could be changed. But the whole thing changed in 2010 with deep learning. The whole world is different now. So with that background, I'd like to say, we humans are not made to do simple things. We cannot draw a straight line, y equal to mx plus c, only two parameters, the slope and intercept. We can't draw that without the tools. Robots can do that. 24/7, 365 days, anytime, anywhere, without stopping. So machine intelligence was good for simple things, not for complex things at all. And we were good at complex things. And we'll be like that. But machines are changing. They are becoming good at complex tasks as well. And the robotics and AI is there everywhere. My colleague in linguistics, she's using AI for her work. And then comes what is known as the fourth industrial revolution, where just like Internet of Things, you have cyber physical systems. Industry 1.0, 2.0, 3.0, we know. 4.0 started recently, basically to connect everything. We are connected. Our things we carry are connected. But there is also Industry 5.0, where human-robot collaboration, customizations, and cognitive systems are happening. So Industry 4.0 is hot now. And different technologies are associated with that, and that is transforming the factory of the future, wherein humans and robots have to work together. And there are quite a lot of challenges. For example, with deep learning, data-driven insights can be obtained, or you can have what is known as digital twins, not the mathematical twins you manage with the transfer functions. And with the help of that, you'll be able to run digital twins to failure. Physical systems cannot be run to failure because the money involved is, the cost associated with that is high. And then you can predict what is known as remaining useful life. And that leads to not reactive maintenance, but predictive maintenance, and be able to optimize assets. So I was talking to someone today morning, I think he's from GE, if I'm not wrong, and he was saying even the old systems, efficiency is not so good because manually it is tuned or humans manage it. Now they are moving away from manual to automation through AI, and the efficiency of existing old systems are also getting improved. And this is on one side. The other side is stronger customer centricity, agile development, and be able to collaborate, and flexible manufacturing. I'm not going to the details. And also that is leading to new marketing and business models where No company is capable of doing everything by themselves. AI, deep learning, and robotics, not everybody can afford to. So people are coming together and developing together, and where CTOs have to come together and work together as a inclusive leadership, while United Nations Sustainable Development Goals are also being managed. And there are risks associated when all these are connected, securing the physical and cyber assets, and how to keep them working and maximize uptime. Now, with that, I would like to say we have to be very mindful about the jobs that are getting shifted. This is World Economic Forum 2025 job report. 92 million jobs will be displaced by 2030. 170 million new jobs will be created, and a lot in robotics and AI. 39% of workers' core skills will change by 2030. Analytical thinking, resilience, flexibility, and agility, and leadership and social influence, all those are core skills now required. And the fastest growing skills by 2030 will be AI and big data, networks and cybersecurity, technological literacy, and more. And if the global workforce were 100 people, 41 would need not upskill by 2030. 29 would be upskilled in their current job. 19 would be upskilled and redeployed. 11 would be unlikely to receive the necessary upskilling. It's changing. Look at the world now with all the tariffs. Why? People are closing their boundaries. The sons of soil, giving jobs for their own citizens, is happening everywhere. And there are a lot of initiatives of this kind. So Make in India in here, and manufacturing renaissance in US. All these are leading to so much redrawing of the boundaries in the technical space. And I would like to urge you, especially the students, don't be a prisoner of the boundaries of your engineering discipline. I'm now working with civil engineers to automate civil construction in Singapore. I did not study civil engineering. I know only robotics and AI, but you can learn anytime. Don't be biased. Don't call yourself as electrical or mechanical or something else. So vanishing boundaries of specializations happening, you have to have multiple skills, be agile and ready to learn new skills. And don't expect you will have one job for your lifetime. There'll be different careers that you have to undertake. With that, I'd like to stop my presentation. I have to leave soon. If you have any quick questions, please do raise. I'll be here for another 5 minutes, then I have to catch my flight. Okay? Thank you very much. Folks, anything? All the best to you. Sorry I had to rush. Okay? All the best to you. I'll stop now here. Can I get this for me? Get that.
Thank you, Dr. Vadakapat, for such an insightful and thought-provoking address. Since Dr. Vadakapat has an important flight to catch from IGI Airport, we would now like to take a moment to convey our heartfelt gratitude to him on behalf of the organizers and the participants. Great teachers inspire, but great leaders leave behind a legacy of inspiration. Sir, we wish you a safe journey and continued success in your endeavors.
Next, I request our next keynote speaker, Dr. Cecil Kumaravadu, Senior Professor of Electrical Engineering at the University of Moratova, Sri Lanka, and Distinguished Professor at Shanghai University of Electric Power. With extensive contributions in power systems and electrical engineering research, he continues to shape innovation in this domain. He will deliver his talk on driving intelligence inside the mind of a self driving car. So, please.
We have
Thank you very much for the introduction. Driving intelligence inside the mind of self-driving car, the talk I gave yesterday. Now, the planned talk this morning is, actually now it's afternoon, is future energy meters. Okay, so to start with, once upon a time, back in 1882, we start with the very first power station, power system, actually in Manhattan, Pearl Street Station by Thomas Edison. Right, according to records, about 500 plus households connected to this power system. Supplied with 110-volt DC. Okay, the generation, transmission, distribution, the utilization, all DC. Now, the birth of electricity industry, so you have to, at the end of the billing month, you have to produce a bill. So there must be a mechanism to quantify the energy supply to each and every household, the energy meter. The very first energy meter, you can see this US patent, 1881, Thomas Alva Edison. That's an electrochemical energy meter, right? You can see there is electrochemical cell at the top, and on your right is arc suppression mechanism. That's for safety purposes of the circuit. Now, electrochemical in the sense is DC. Okay, at the end of the billing month, you measure the weight gain of the electrode, and you take that to be proportional to the amount of ampere hours delivered to that particular household. And you assume that
the supply voltage is more or less constant 110 volt DC, right? So as a result, you insert a plate, copper plate at the beginning of the billing month, and you take it out at the end of the billing month, way up, the weight difference, the mass difference is proportional to the ampere hours delivered as electrochemical meter, right? And within the same to 1890 period came the mechanical meter. All right, it's basically synchronous and then with AC. All right, AC, Westinghouse, the Tesla, came the mechanical meter. That's basically a small synchronous generator. Then came very few years later, within the same decade, the spinning disc, that's the induction meter that dominated the electricity industry for about a century until the smart meter comes. Now, today, the era of smart meters, how about something like this? Have you seen the energy bill? Your home is receiving energy bill every month. Have you received that? So it shows the monthly consumption in kilowatt hours and the bill. How about energy bill, right? That not only show you the aggregate power, the total energy consumption during the month, but also what you call an itemized bill that shows the energy consumption of each and every appliance in the house, right? So that you can make some informed decisions about energy management. Reduce, what ways you can reduce the energy bill. At the same time, with some recommendations, maybe a recommendation like your air conditioner seems to have run the bypass mode more often than not, unusually long time during this period, and you would like the technician to come and take a look, right? Maybe a sensor failure, maybe undersized air conditioner, maybe poor installation, lot of thermal losses can be the reasons. And do you have experience forgetting to turn off the electric iron? Have you ever forgot to turn off the electric iron? That happened to me. And how about a smart meter that can alert you, send you a SMS message saying, look, your electric iron seems to be in the on state for unusually long time. You would like to go and take a look. That's a smart meter. The important point is this. NILM, non-intrusive, is the key word. Non-intrusive means without using any intrusive sensors. We don't use any sensors inside the household. It's just the meter, right? Whatever you do is done at the metering point. That's why called non-intrusive load monitoring. All right, how do you do that? How do you produce an itemized bill at the end of the billing month without intrusive submetering, without entering the house, being at the metering point? How do you generate a SMS alert if something unusual is happening without having any sensors inside the house? Your energy meter, that's sitting outside the house, right? So let's see, try to understand first and foremost how we do that. And with the use of artificial intelligence, deep neural networks, deep learning, and what challenges ahead in terms of realizing this kind of a smart energy meter. Good. We are talking about itemized bill at the end of the billing month, maybe in the form of a pie chart, right? That people can easily understand. Now, all right, how do we do that without using any sensors inside the house? Purely at the metering point. How do you do that? Now, if you take any electrical appliance has unique power signature. Let's take a look at some simple examples. All right, electric kettle gives a kettle burst, some high power, about 1.5 kilowatts, 2 watts power for a short period of time, and then off time for a very long period. High power burst for a short period and off for a long period of time, right? And your refrigerator will be on for a short period, off for a short period, again off. It goes on-off cycles. That's the temperature control cycles, on-off. Maybe also, your air conditioning system with on-off control. Power on, power off, right? Little power during the off stage because you have the air circulation fan still working. Good. And we look at that goes like on, off, right? Kettle goes like high power on for a short period, off for a very long period. And we look at a light bulb, it's pretty much consistently on, small power for a longer period, right? Now, in artificial intelligence, how does the artificial intelligence achieve this kind of a task? Use the features, right? Even face recognition, your face is recognized based on the features. Good. Now, what are the features? The transient features. The switching transients, when you turn an appliance on, you see a spike. When you turn it off, you see a spike, downward spike. Good. And then you have the spatial features, transient features, spatial features, just like the features of your face. The artificial intelligence face recognition systems using to identify your colleague or your family member. Got transient features, spatial features. What are the spatial features? If it's an on-off air conditioner, on period, off period, on, off. It keeps going. Good. And if you have automatic washing machine is different. And there you have a sequence of events, timing, okay, spinning, the washing, okay, and then various a sequence of events in an automatic washing machine, and each event consumes a different level of power. So this kind of appliance we call multi-state, several states when it's operational. Those are called spatial features, right? What are the other features? Now, okay, let's say you have two washing machines. You have two electrically identical air conditioner units. How do you differentiate them? Even though you have multiple appliances electrically identical, nameplate data, now you'll have to use things like what you call temporal features. Temporal features means the usage patterns that depends heavily on the user behavior. Let's take a look at example, a kettle in the kitchen, right? The way it is used, the frequency, right, and the time of the day, the different from the kettle in the office. Good. So those are called temporal features, transient features, spatial features. Pretty much characteristic to these appliances. And temporal features pretty much characteristic to user behavior, the persons who use these appliances. On top of that, you can have what you call the noise, right? The harmonics that are characteristics to the power electronic circuits you use, the nature of the circuits in your appliance. So basically, artificial intelligence uses these features to separate, to disaggregate the power profile of each and every appliance from the aggregate power profile. That is non-intrusive load monitoring. All right, so for example, think about an orchestra. In an orchestra, you have a drum beat going like burst, right? And rhythm guitar on-off, sort of like on-off patterns of a refrigerator. And the violin beat goes low level, pretty much continuous. Good. What you're talking about is rather than producing the sound pattern of each instrument in the orchestra by recording the sound at each and every instrument, you record the total pattern, right? The overall, the orchestra, the sound. You use artificial intelligence to disaggregate and produce the sound profile of each and every instrument. That is exactly what is happening here. So instead of sound, here we have power profile, how the power varies with time. During the entire month, you're talking about billing month. Good. Okay, let's take a look at this example. Now here you can see this is a three-phase case. Now at the top you have the three colors representing the power profile of the three phases. Okay. Now at the bottom you have the power profile of inverter air conditioner single phase. Good. Single phase inverter air conditioner. And if you look at the bottom, the orange color one is the reconstructed profile by artificial intelligence. The other one is the actual profile. Actual profile and the prediction. Prediction is the predictor model of your deep neural network. Okay, this is what you're talking about. We understand that it's very difficult to catch the exact value at each and every instant of time. We're not talking about that. We're talking about, okay, estimating the individual power consumption during the billing month to plus and minus X% accuracy. Good. So that you can get some idea to make informed decisions about energy management. Informed decisions about potential anomalies, right? Your on-off air conditioner is operating without turning off. You say, in control engineering terms, we call it the bypass mode. There's a problem in the temperature control. So this is what you're talking about. In this lecture, particularly, I emphasize three-phase loads. Okay, three-phase loads are much challenging than single-phase loads, particularly when your three-phase system is unbalanced. I'm not talking about transmission distribution. We're talking about a building, right? Building has a balanced three-phase supply, and the building has unbalanced three-phase load. So what makes three-phase load unbalanced? When you say unbalanced three-phase load, a three-phase load becomes unbalanced because when you have the three-phase loads and single-phase loads that are unevenly distributed among the three phases, right? Because single-phase loads are unevenly distributed among three phases, the three-phase load is unbalanced. So that's, you can see here, the power profiles are different. That's because three phases are unbalanced, and that unbalance is not a constant that changes over time. Okay, different moments, completely different scenarios. Now, how artificial intelligence can look at those aggregate power profiles, the three aggregate power profiles, and disaggregate them and produce the individual power profiles of each and every appliance at your home, so that the power profile during the billing period can be integrated, time integrated to produce the total energy consumption. You know what I mean? You integrate power, you get energy. Okay. This is what you're talking about. Okay, we train a neural model for each and every target appliance. Each and every target appliance. Particularly, we are interested in high power consuming appliances, right? And then, during the disaggregation, while in operation, we feed all three aggregate power profiles of all three phases to each and every neural model. And then, now this one is trained, the first one, if you look at, okay, so P1K, trained for NN1, that's the neural network 1, trained for one appliance, let's say appliance number 1, appliance number 2, appliance number 3, it goes to appliance number N. Good. So you feed the aggregate power profiles of all the three phases to all the models, and that model is supposed to produce the power profile of the target appliance. The power profile of the target appliance. How do you do that? Disaggregation. You can see the deep neural network model we use. And you feed the power profiles of all three phases, right? Think about this model as supposed to produce the power profile of the target appliance. Okay, now you have a deep neural network. It's a three-stage process. Now, in the first stage, early stages, we use on-off classifier. Okay, on-off classifier to find out whether the target appliance is in the on state or in the off state. Okay, we use WaveNet neural architecture. Use the WaveNet neural architecture to find out your target appliance is in the on state or off state. So basically, your WaveNet looks at the aggregate power profiles, all three, to find it out. And that at each and every instant of time, maybe every 1 second, every 6 seconds, become the input to the deep layers or the deep network. In my case, it's CNN, convolution layers. The convolution layers gain the on-off state, right? Plus the aggregate power profiles. And it extracts the features. So the deep networks, CNN layers, basically extracts the features of the target appliance. Okay. Now we know that we discussed about features. What are the features? Transit features, spatial, temporal, and maybe some fine features like, noise, the harmonics. And they become the inputs to the back end that, in our case, again, WaveNet, that is a regression model. The regression model, it predicts the power value. Each and every time instant, it predicts the power value of the target appliance, right? Each time instant, it outputs the power value, right? Now, when you put them together, the sequence of data that goes to the end of the billing period, and you time integrate to find the total amount of energy. So that's the three-stage process used by the artificial intelligence deep neural network to produce the power profile of the target appliance by taking into account the aggregate power profiles, the three phases as the inputs. Good. There are certain points I leave to you to ask in the question and answer sessions. The disaggregation, what do you do? That's what you do. Disaggregation is the training process. First and foremost is to train your models. Just like a human intelligence, the training is required, right? How do you train? In the training, we use aggregate power profile data, all three phases, and the power profile data of the target appliance. So what do you expect? You expect the deep network to learn right? Learn to disaggregate and reproduce, okay, the power profile of the target appliance. Now, if somebody asks, why do we input all the three aggregate power profiles? Why not aggregate profile of that particular phase? Anybody thought about that? Okay, we are talking about, if you want to disaggregate a single phase load profile, why do we need the aggregate profile of the all three phases? Why not aggregate profile of that particular phase? All right, I'll leave you to think about it and we'll discuss. Okay, let's take a look at some examples. Now in here, these are some results. All right, you can see the three phases. Okay, one of the phases have a single phase load during this time. Disaggregation. Without using all three inputs, these three phase case. If you disaggregate without using the aggregate profiles of all three phases, this is what you get at the bottom. The red lines, the bottom. You can see the accuracy is not very good. So you can see that you have the target, you have the predicted profile by your artificial intelligence, and you have the actual profile. So you can see when you don't take into account all the three aggregate profiles as inputs, the performance is poor. The reason is that in your mix, you have three-phase loads and single-phase loads. When you feed all three aggregate profiles, the AI can look at all these three and see the differences and the common features, and that enables it to separate, differentiate the three-phase loads and single-phase loads, right? That is one reason. The second reason is we never know. Your electric iron, you may plug in on the first floor today, you may plug in on the second floor tomorrow. So it's a different phase. The single phase loads may be moved among the phases without informing the smart meter, right? You never know where the single phase loads are. This is another example, right? The risk of drowning is that the power profile of small power appliances disappearing in the ocean of large power appliance power profiles that we call drowning or masking effect. So you can see, again, the same result. At the bottom, the red lines show when you disaggregate without using all three aggregate profiles, the performance is not very good. This is interesting. Now here, this is again three-phase. You have a single phase, a milling machine that's completely in the off state during this period. It's in the off state, right? You can see the phase power is close to 6,000 for a certain period of time. After that, almost 10,000 the power of three phases. But there is a single phase milling machine that's totally in the off state. However, if you don't use, without using on-off classifier, it produces a noise signal just like this, some small power, right? You can see this is the predicted power profile. You can see here, okay? Actually, it's not drawing any power. So this is not true. This is wrong. Even though these power values are small, okay, a few tenths of watts, this is not true. The truth is the milling machine is completely in the off state. So, but if you use the on-off classifier before the CNN deep layers, right, you get exactly a flat line showing that this device is totally in the off state during this period. All right, so Good. Ensemble learning, I encourage you to read this publication that's available in IEEE Explore, right? We know that just like a human brain, artificial intelligence has its own limitations. It forgets sometimes. When you train, when you do a lot of training, it tends to forget what it saw at the beginning. Right? There are memory issues. And what we realize is that when you keep training, right, the neural models, okay, in the initial phase, let's say, for instance, the first 5,000 training epochs, the features it capture are not captured as well when you go on to the 5,000, 10,000 training epochs. But it captures some other features better. When you go further, maybe 10,000 to 15,000 training epochs, it captures certain other features very well, and it tends to forget what it learned at the beginning. So what it did a very simple thing, very simple. Okay, we train the model 5,000 epochs, save that model, basically the connecting weights, right? Say the parameters. And then 5,000, 10,000 weights update, neural network learns, right? I'll stop, save, and then you go 10,000, 15,000, stop, save, and then combine them. This is called ensembling, right? It's in music industry, say ensemble, different instruments. Ensembling techniques are very popular in artificial intelligence. We usually use the strengths of different neural architectures, right? So that we can put them together and bring about what you call the synergetic effect, right? Just like the human brains have, strengths and limitations, right? Some of your colleagues are really good at solving problems, but not good at remembering things. It's forget things, right? Just like that, we use numerous different neural architectures. Up to this point, I mentioned at least two, right? The CNN and WaveNet, and transformer models. The ChatGPT uses transformer models. There are a number of different models. So we combine them to bring about a better model. It's techniques called ensemble techniques. I invite you to read more about that. It's available here. Now, some further tests like to highlight. Okay, if you look at in this mix, you have a washer dryer, basically washing machine with dry functionality, and single phase, dishwasher, single phase, water pump, single phase, microwave, single phase. And you have how many fridges? Fridge 1, 3 phase, fridge 2, 3 phase. There's an exhaust fan, it's 3 phase. There's another washing machine that is 3 phase, right? You have inverter AC. We'll discuss inverter AC is very challenging. There are two of them in the mix. Okay, let's take a look at the performances of training. This is the most interesting of them all. And we know that if you take a water pump, power bursts for a short period of time or for a long period of time, it's very easy to catch them, differentiate them. But if you look at on-off air conditioner, right? On-off air conditioner, your temperature controller will keep the refrigeration cycle on for some time. When the temperature drops to the set value, it turns it off. It's off period, right? And your condenser is also off. Entire refrigeration cycle is off. Only the air circulation fans running. Temperature starts to rise. The temperature has risen to the set level. Again, the refrigeration cycle comes on. Now the power fully on. So power fully on, right? off, but only little power because the circulation fan. So it goes on off cycles. We call duty cycle. Duty cycle determines how long is the on period, right? And the ratio between the on duration plus off duration. Now, here it is different. What is the difference between on-off temperature control of an air conditioner and inverter control of an air conditioner? In the inverter control, you don't turn off the refrigeration cycle. You adjust the cycle speed, right? You adjust the cycle speed. So then what happens is there are no on-off patterns. When there are no patterns, it's very difficult. There's a shortage of features, right? The power profile varies continuously. There's no idea. You have no idea how it's going to vary because it depends on many things. Depends on the load, depends on the thermal leakages, depends on the outdoor conditions. Outdoor conditions may be very favorable, right? A low temperature day, say rainy day, but on a very hot day, outdoor temperature is 37 degrees Celsius, very unfavorable. So it depends on the outdoor conditions, the load, the thermal losses, the sizing of the air conditioner. Unit maybe it's oversized or undersized, and the installation. So what we have found is inverter air conditioner is the most challenging. But still, you can see here, the target is the actual power profile. The prediction is the reconstructed power profile by artificial intelligence. Okay? You can see at the center, there are on-off profiles because the modern inverter air conditioners also have on-off control. When the inverter load is low, when the inverter efficiency, particularly your compressor efficiency is low, right? That's not very good. You don't want compressors to work at very low efficiency levels. So the system switches to on-off temperature control so that when it's on, your compressor can work at a considerably higher power level. When it's off, it's time to rest, time to cool down, right? It's off. So that's a much favorable option during low load period. So you can see this air conditioner has inverter mode as well as on-off mode. And this is beautiful. This is the most beautiful picture as far as the different appliances we consider. Let's take a look at other ones, right? Washer, dryer. There are on periods, off periods, different power levels, right? This is basically automatic washing machine, all right? So it's a multi-state appliance. You can see, again, the target. That's the actual power variation with time, and the prediction is reconstructed by AI models. Dishwasher. And then we have the microwave. This is very simple. Microwave can have several stages, right? Here is two-stage microwave. Okay, so we are looking at the disaggregated power profiles of this mix. This is the mix. What is the mix? I showed you the mix, right? Yeah, here. This is the mix. Now we are looking at individual reconstructed power profiles. Okay. We looked at this and this one. This is relatively much easier. This is water pump. Water pump means sometimes half a kilowatt, 1 to 3 kilowatt for a short period of time. It's off for a long period of time. Very easy to catch because the features are sharp. When there are sharp features, consistent, the job is easier. But the features are inconsistent, inverter air conditioner are relatively tough. This is the fridge. As the fridge 1, okay. And we have the fridge 2, you can see on off, right? It's an exhaust fan that's tough again. Exhaust fans, the on state all the time. Once it's turned on, you can see that is tough. You can see the absolute relative error, average error, rather, absolute average error. Now, it's 93% compared to 99, 90, almost 99, right? Almost 100% during this period, but this is relatively low. You can understand why. Because the fan is always on, right? The load on the fan, depending on the wind, etc., the pressure difference can vary. You can see it looks quite noisy. Okay, there are no on-off patterns. When there's a lack of patterns, the features, that becomes tough, not only for artificial intelligence and for biological, the human intelligence. Good. Okay, we're running out of time. I would like to take a look at some examples. This really interesting. Okay, 4 air conditioners in my university. You can see finally a project room. There are 2 air conditioners. Now, one has been regularly maintained, the other not. I'm not quite sure. Don't ask me why. The power electronics lab, you can see there's issues with maintenance. The AC units are on-off type, identical, electrically identical, right? You can see the thermal capacity, the same, the input power expected. Now, during these experiments, the set temperature and the outdoor temperature remained constant, more or less. Look at the power profiles. Okay, on the left, power electronics lab. You can see the top one, 4,000. The bottom one, almost 4,000, but there are some noisy sort of behavior. Okay, what is the observation? It's not turning off. Your air conditioner is on-off type, but it's not turning off. The most common issue is undersized. The air conditioner is undersized and it's running non-stop. If you look at on the right, okay, the same, finally a project room. If you compare the one at the top and the bottom, there's a difference, this much of a difference, 750 watts different, identical air conditioners. You can see what happens when there is no maintenance. When there's no maintenance, maybe the lubrication, right, the dust accumulation of the fans, the compressor, they consume more power. If you do not, you can see this is a good example. More power, right? So it can be aging. It can be component degradation that happens over time. Now, what are the challenges? Now, one of the big challenges when you install your smart meter, NILM enabled smart meter, you cannot go inside the house and say, look, it's been 5 years, we have to retrain. You cannot do that, right? You cannot retrain. Okay, so what is the option? Your smart meter, the NILM models should be able to, what you call self-learn, self-adaptive, self-learn, self-adaptive. Just like you get your driving license, after getting the driving license, you drive and you learn yourself. And there's no training process offline. AI to learn itself, right? Okay, so that's a very important topic we cover in this publication. You can take a look. So what you do is there are methods such as pseudo-labeling and transfer learning. This is a very important point, that is self-adaptive. The takeaways is that I strongly believe that this is possible. You can see the applications of artificial intelligence is numerous. It's not just about face recognition or voice recognition, speech processing. You can think about a lot of numerous applications in power engineering, and other fields of engineering and technology to solve problems better, faster and cheaper. In this case, you can see doing it without sensors inside the building. That's the point, right? You have only sensor, the power sensor at the metering point and nothing else. And we hope to share our latest findings. We hope this can be realized within years in time to come. Wish you all the best. And we can have, if you have any questions, if the time permits, we can. Yeah. Privacy. Yeah. The privacy. Now, the data belongs to the utility. The utility has to ensure the privacy. Yes. I mean, what you say is right. The utility can find whether you are at home or not. Right. So then there must be a privacy protection agreement and guarantee by the utility, because the meter belongs to the utility. Yes, that's excellent question. Any more questions? Yes.
Sir, as the model is trained with the previous technologies and the technology that we're using in today's date, so the technology is rapidly evolving. So how can we train the model to evolve that fast with the rapid technology?
With the technology?
Yes, sir.
Yeah, the task is to produce an itemized bill without having sensors inside the house, right? Sitting at the metering point. Thank you for the question. So that's what we are going to achieve. On top of that, you forgot to turn off the electric iron, right? Create SMS, and then make sure that there are some recommendations at the end of the bill. So your bill has, unlike the today's bill, okay, aggregate power, total power during the billing period, the charge, okay, plus itemized bill, each appliance, how much power, plus some recommendations, such as your air conditioner has been on the bypass mode for too long. Maybe get an technician to come and check. Now, these are the challenges. What are the other challenges? Like I mentioned, the three-phase system, special challenges, and then aging. Aging means 5 years later, because just like AI uses the features of your face, features of your voice to recognize, AI uses features here. It's called feature drift. Over time can happen, right? With the aging component wear and tear degradation, it's called feature drift. Now, that's what the final mentioned, self-adaptive. And the AI has to learn itself without going inside the house, right? I mean, read the paper is possible to a certain level, but there's a lot of work to do. Your question is, actually, the new AI models are coming, like transformer models that we did not discuss, this temporal model with self-attention. New technologies will make job easier. So maybe tomorrow it will be relatively easier than today.
Thank you, sir.
Thank you for the question. Okay, thank you very much. Thoroughly enjoyed the session.
Now I would like to invite our HOD, Dr. PM Tiwari, to present a gift to Dr. Cecil.
I request Dr. V.K. Tayal sir and Dr. S.K. Sinha sir also to join for the photograph. Kamlesh sir also.
The best way to predict the future is to invent it. Thank you, Dr. Kumaravadu, for that inspiring talk.
Moving ahead, it is my privilege to invite our next keynote speaker, Mr. Pradeep Chaturvedi, Vice President of the Indian National Academy of Engineering and Vice President of the World Environment Foundation. A distinguished leader in engineering and sustainability, he has been at the forefront of advancing environmental management, energy policy, and sustainable development initiatives in India and beyond. He will speak on electric vehicles and sustainability. Sir, I would now like to invite you.
Sir, you have to unmute yourself. Sir, you are muted.
Yes,
Please
I'm
unmute.
yeah. Now you can hear me.
Yes.
Okay. Thank you. Thank you. Thank you very much. I'm grateful to the MIT University for inviting me to the 6th International Conference on Recent Development in Control, Automation, and Power Engineering. It's a great pleasure to be speaking at any of the functions of the MIT University, which has done great job and is being recognized world over for the contribution that they are making in India and abroad. Now, I've just chosen, I'm not making a highly technical presentation, but on the policy issues that we have been considering as to what needs to be done on electric vehicles and their contribution to sustainability. But where does technology drive the future? Where does the technology stand, and what are the challenges that you must try to understand that is important? And I'll try to finish in the remaining time, maybe 15 minutes that you have. The global transportation sector is undergoing a seismic transformation. For over a century, internal combustion engines vehicles powered by fossil fuels have dominated roads worldwide, fueling economic growth, but also contributing heavily to environmental degradation. According to the International Energy Agency, transportation accounts for nearly 24% of global CO2 emissions from energy use, making it one of the largest single contributors to climate change. The harmful impacts are evident not only in the rising global temperatures, but also in deteriorating air quality, public health concerns, and increasing dependence on finite fossil fuel resources. Against this background, electric vehicles have emerged as a compelling and technologically viable alternative. They are no longer a futuristic concept, but a rapidly maturing reality that is shaping the very foundations of mobility. The convergence of advanced battery technology, renewable energy integration, smart infrastructure, and digital connectivity have placed EVs at the forefront of sustainability movement. This transformation is not merely about replacing gasoline engines with electric motors. It's about rethinking mobility to make it cleaner, smarter, and more equitable for future generations. Now, EVs are a cornerstone of sustainability. One of the most powerful arguments for EV adoption lies in their potential to significantly reduce greenhouse gas emissions. Unlike traditional vehicles, EVs produce zero tailpipe emissions, which directly contributes to improved urban air quality. When charged with electricity from renewable sources such as solar or wind, the life cycle emissions of EVs can be up to 70% lower than that of the internal combustion engines. This makes them critical to achieving national and global net zero carbon targets at an early date. Beyond emissions, EVs are inherently more energy efficient. Electric drivetrains convert over 77% of the electrical energy from the grid into usable, power at the wheels, compared to around 30% of the internal combustion vehicles. Regenerative braking systems further enhance efficiency by recovering and storing energy that would otherwise be lost during deceleration. EV adoption also brings social and environmental co-benefits. Reduced noise pollution improves quality of life in urban areas. Electrified public transportation, such as e-buses, e-rickshaws, and light rail, offers sustainable mass mobility solutions, helping cities reduce congestion and improve accessibility. Now, the technological drivers of the EV revolution. The rapid advancements of EVs is being propelled by an extraordinary range of technologies, each playing a critical role in overcoming adoption barriers and improving performance. The first of them is the battery innovations. Batteries are the heart of any electric vehicle. Currently, lithium-ion batteries dominate the market due to their high energy density, relatively long life, and declining costs. However, the future promises even more breakthroughs. Solid-state batteries expected to reach commercial scale later this decade could offer double the energy density of current lithium-ion cells, significantly faster charging times, and improved safety by eliminating inflammable liquid electrolytes. Battery management systems ensure safety, efficiency, and longevity by monitoring temperature, voltage, and charging cycles. At the same time, advancements in recycling technologies are beginning to address the environmental and supply chain challenges associated with battery production. Second life applications such as repurposing EV batteries for stationary energy storage offer additional sustainability benefits. The second part is the charging infrastructures. Charging technology is evolving at an impressive pace. Fast charging stations can now replenish up to 80% of the EV's battery in under 30 minutes, dramatically reducing downtime. Wireless charging systems, still in early stages, promise even greater convenience by allowing vehicles to charge via induction pads without the need for cables. Perhaps the most exciting development is vehicle-to-grid technology, which enables EVs to not only draw power from the grid, but also feed excess stored energy back into it. Combined with smart charging systems that optimize electricity use based on demand, cost, and renewable energy availability, vehicle-to-grid turns EVs into active participants in energy management. The third point is the connected and autonomous features. Modern EVs are increasingly equipped with Internet of Things integration, enabling real-time monitoring, predictive maintenance, and fleet optimization. Over-the-air software updates allow manufacturers to improve performance, enhance features, and fix issues without requiring physical service visits. When combined with autonomous driving systems, electric mobility has the potential to optimize traffic flow, reduce accidents, and revolutionize personal and commercial transportation. The fourth part is the lightweight materials and the aerodynamics. Advanced materials such as carbon fiber composites and aluminum alloys are reducing vehicle weight, thereby increasing range and efficiency. Aerodynamic designs from sleeker body shapes to underbody panels minimize drag and further improve performance. Now, the challenges to widespread adoption of the electric vehicles. While the progress is remarkable, several challenges must be addressed for EVs to reach mass adoption. The first of them is the battery supply chains present a significant hurdle. The production of lithium, cobalt, and nickel, the critical raw materials for most EV batteries, raises concerns about environmental impacts and geopolitical dependencies. Sustainable and ethical sourcing alongside investment in recycling infrastructure is essential for long-term viability. The charging infrastructure gaps are another major concern, particularly in rural areas and developing regions. Without convenient and reliable charging options, range anxiety remains a barrier for many potential buyers. Investment in fast charging corridors, urban charging hubs, and home-based solutions is crucial. Cost barriers still exist despite falling battery prices. While electric vehicles often have a lower total cost of ownership due to reduced fuel and maintenance expenses, their upfront price remains higher than internal combustion engines vehicles. Continued subsidies, incentives, and scaling of production will help close this gap. Finally, grid readiness must be addressed. A surge in electric vehicle adoption will increase electricity demand. Integrating renewable energy sources, modernizing grid infrastructure, and deploying smart grid technologies will be key to meeting this demand sustainably. The policy and the regulatory framework is the second set of support mechanisms that will help EVs to move at a faster pace. Governments worldwide are playing an important role in accelerating EV adoption. Purchase incentives, tax breaks, and registration fee waivers make electric vehicles more financially attractive. Stricter emission standards are pushing automakers towards electrification, while research and development grants are fueling innovation in battery chemistry, charging technology, and sustainable manufacturing processes. Public procurement, such as the electrification of municipal bus fleets, demonstrates government commitment and helps create early demand. Regulations promoting interoperability between different charging networks and standardizing plug types are also critical in improving user experience. The opportunity that our country has. In India, the EV market is projected to grow exponentially, driven by supportive government policies, rising environmental awareness, and advances in local manufacturing. Programs like the FAME India scheme, that is faster adoption of manufacturing of hybrid and electric vehicles, provide subsidies for both vehicles and charging infrastructure. The recently announced battery swapping policy addresses charging convenience and operational flexibility, particularly for commercial fleets. Urban air quality mandates and green mobility targets are encouraging the use of EVs in public transport, taxi services, and last mile delivery. By leveraging its manufacturing capacity through the Make in India initiative, the country has the potential to become a global hub for EV production, components, and battery systems. EVs are as an energy assets. EVs are more than just vehicles. They are mobile energy storage units that can integrate seamlessly into broader energy system. Vehicle-to-home systems allow EVs to power households during outages, while vehicle-to-grid enables them to stabilize the grid during peak demand periods. When charged during periods of high renewable generation, EVs can act as distributed storage assets, reducing reliance on fossil fuels and improving grid reliance. Where do we look forward to? Looking forward, we can expect dramatic advancements in EV technologies over the next decade. Solid-state batteries are likely to become commercially viable, extending driving ranges and reducing charging times. Artificial intelligence will increasingly be used to optimize fleet operations, predict maintenance needs, and manage charging schedules. Solar integrated EVs may generate a portion of their own power, further reducing grid dependency. Bidirectional charging would become standard, allowing EVs to participate fully in energy markets. But the R&D intensity that is required and the investments, the high levels of investments that are being called for the deep tech development are tremendous. So it's not easy to think that it's an easy switch over, but it will be a combination. We can make the move and look forward to where we go by 2030. The technology would really be the enabler, but at what cost? This support has to come. It can't come only from the government, but large part of it will come from the auto manufacturers, to battery manufacturers, and the private sector. How are they being attracted remains a big challenge, and Only when there a combination of the financial support and the technology support from the private sector matches with what the government policies are offering, we can move at a much faster pace. Electric vehicles are more than a transportation solution. They are a central pillar of a global strategy to combat climate change, improve urban living, and create sustainable economic opportunities. The combination of cutting-edge battery systems, intelligent charging infrastructure, renewable integration, and connected vehicle technologies is transforming the automotive landscape at a pace unmatched in history. Yet technology alone will not be enough. Achieving the full potential of EVs requires a collaborative approach involving governments, industry leaders, innovators, and consumers. It requires ethical supply chains, equitable access to infrastructure, and a commitment to integrating sustainability into every step of the value chain. If we succeed, the vision is compelling. A future where clean mobility is accessible to all, where cities breathe cleaner air, where transportation is seamlessly connected to renewable energy systems, and where technology serves not only the driver, but the planet itself. In this future, electric vehicles will not just move people, they'll move humanity towards a sustainable and prosperous tomorrow. Thank you very much.
Thank you, Mr. Chaturvedi, for such valuable insights and for guiding us through emerging dimensions of research.
Finally, it gives me great pleasure to invite our fourth keynote speaker, Dr. Sanjeevi Kumar Padnaman, professor at the University of Southeastern Norway, a prolific author and one of the world's top 2% scientists. He is renowned for his pioneering research in power electronics, electric drives, and renewable energy integration. He will speak on AI inspired renewable smart power electronics applications.
Very good morning to all, and I'm sorry first of all for delayed connecting with the Zoom because of some technical issues. First of all, I'd like to thank Amity University and Professor Tiwari for inviting for a wonderful such events. About my presentation today, I like to focus on AI-inspired renewable smart power electronics applications, what we are working for 2 to 3 decades with my PhDs and postdoctoral researchers. Currently, the entire globe is moving towards renewable energy and to compensate various CO2 emissions. Particularly in Norway, if you look at the statistics in the context of Scandinavian countries, Norway already in as a forefront in the player with adoption of more EV. The statistics which I am showing is around 2021. The updated statistics is around 94% plus electric vehicle and large scale deployment of EV chargers are deployed in the entire country. And almost the clean energy technology is around 99.23% free of CO2 emission. And Oslo city is the world best for CO2 compensation or a clean city in the world. These are because of the technologies and adaptation of modern artificial intelligence technologies and, of course, power electronics and integrated with renewables. Norway goals is around 2035 to become 100% EV, but I believe in 2026 or 2027 probably will be 100% EV. And the country's expectation is to become 78% reduction in 2035, 100% by 2050. But current statistics is 99.2% of clean energy. These all informations are available in online database. Per minute, per second, estimations are available from Norwegian official government websites. Whichever energies we are using, particularly for electrification on all sectors, mostly from hydropower plant. Thanks to the nature, Norway has more than 1,000 plus hydroelectric power plants around the country, and most sustainable with electricity grid. Of course, companies from Norway like Statnett are developing many projects in India, in our country, particularly in Gujarat and other parts of Orissa, Assam. These electrification technologies has been transferred from Norway. Here, the critical aspect is the development of information technology. By using IoT sensors, big data will play a critical role in Indian future expectation. By 2070 is our Prime Minister's goal to become India 100% renewable. So where we play with power electronic circuits, smart grids, with more microgrids focused on isolated or standalone mode, because each municipalities or each states or each sectors can depends on their own energy production, does not depends on the main grid. So here Norway has played a important role not only in EU contest but also across the globe, how to become more efficient by using AI technologies and more adoption of renewable energy sectors. So we have to use more IoT based sensors, large scale big data, cloud computing, and machine learning algorithms to optimize all these extension of renewable energy systems. Currently, the deployment is focused towards developing countries and developed countries where there are percentage of power generation from coal or thermal energies are still existing, which are connected to the transmission lines, then to the distribution sectors, which can pump the powers to the commercial areas, residential areas, and of course, charging the electric vehicles. So statistics says that in 2030 we will be having more than 350 billion batteries revolves around the world. A small energy technologies based on lithium ion, and of course new technologies are going to come across with batteries. But now 2030 is our goal, where we are going to have more than 350 million batteries revolves around the world, and major players will be India and China. So in this case, each batteries we can use as a energy market where the batteries can pump the power to the main grid, and each vehicle owner can become an entrepreneur to deal the market by gaining the margin. So all these contests we need to have a large scale AI based, artificial intelligence based aggregators which can able to monitor each power scales, integration with the vehicles, residential units, commercial units, and the percentage of CO2 emission comes from which sort of energy generations. Where plays smart electronics applications? So, in case of the future, in few years, all the non-controlled devices. I mean, currently we are using chargers by using diodes, which is an uncontrolled devices which can create a lot of reactive power to the grid and makes more efficient down. So in future we are going to have more power electronics converters. Obviously, the European Commission has started a decade before many guidelines deploying silicon carbide and gallium nitride devices for high switching frequency, high power density, and high scale efficient electric vehicle chargers. Not only the chargers but also the deployment within the electric vehicles is an example. About the alternative fuels, India is going to be the largest hub in few years' time, which is one of the initiatives from the government of India to a large scale deployment of fuel cell. So fuel cell, why the market is very big? Because it can be used for minimum power of 50 watts to the maximum 100 megawatt capacity, and the temperature scale between minus 20 degrees centigrade to greater than 800 degrees centigrades, which can be applied for high power applications or low power applications. Particularly in case of electric vehicles, we can use for small vehicles or large vehicles. For example, phosphoric acid fuel cells, which can be used for large vehicles, not only for road transportation but also for marine transportation. So indirectly, marine transportation is the huge CO2 emitters. Luckily, Norway in 2026 going to release big ferries based on fuel cell, and of course, India is a key player going to happen with large scale fuel cell production. So if you look at phosphoric acid, it can be used for high power applications with a scale minimum of 1 kilowatt capacity to 10 megawatt capacities, and this can be used between a temperature 80 degree to 300 degrees centigrade. So it's the feasibility of using fuel cell is very large. And look at the prospective areas. Many CSIR labs, particularly in Dehradun and Roorkee, they are working on developing new fuel cell electrolyzers which can able to produce more efficiency than 60%. Currently, the efficiency of these fuel cells are limited. So the deployment of electronics converter become mandatory to enhance the capacity. So there is a huge market in the future across the world for fuel cell to replace the powertrain in electric vehicles. If you look at the electric vehicles internal power stages, we have fuel cell based electric vehicle where we have a hydrogen storage tank. It will be given to the fuel reformer. From the fuel reformer, it goes to the fuel cells where the efficiency, you can have a typical efficiency is only 60%. Then we are using advanced electronics converters which are based on DC to DC to increase the power scale. Then we are using inverters to drive the modern motors which include synchronous or asynchronous machines with linear characterizations. If you look at the cost of the hydrogen production is very expensive. So it requires minimum $150 per generation, and which is a big challenge before the chemical engineering aspects as well as power engineering aspects. In order to compensate the cost, we are using batteries. Again, battery technologies are based currently on lithium ion, and the durability is limited because lifespan of batteries are only limited to 8 years. And many aspects we are going for a second life of battery, but second life of battery doesn't going to help for EV or utilizing in grid connected applications because lithium ions are not renewable sources. So in this case, ultra capacitors, we are working on the project based on super capacitors and ultra capacitors based on companies, where the ultra capacitors will have a greater effects to replace the batteries because ultra capacitors doesn't require state of the charge, or it can be charged from AC or DC, and the lifetime for charging is 1 million times. We can't compare with batteries. Batteries lifetime restricted to 1000 cycles or 2000 cycle maximum, but ultra capacitor life cycle goes beyond 1 million. That shows the greater market for ultra capacitors and super capacitors. And in this case, if you look at the characteristics of batteries and ultra capacitors, batteries are slow transient to reach the rated power or ramp up the power, but ultra capacitors are quick. Within 5 milliseconds, they can reach the rated frequency and rated power. So the comparison between battery and ultra capacitors has a big margin of difference. So the latest technologies focused on electric vehicles deployments, ultra capacitors will play a critical role. For example, if you look at a large scale electric vehicles, then we need a DC microgrid within the electric vehicle. For example, marine transportation systems or large trucks where we are going to deploy fuel cells integrated with large scale batteries, maybe in the range of 600 to 700 volts. And these all are controlled by a small actuator, which is a DC to DC converter, electronics converter, to maintain the common point of coupling, which is a DC microgrid. Around now we are using 400 to 800. In the future, it's going to be a 1200, 1600 scale because the power requirement is increasing very high level. On the other part of the propulsion systems, we are using inverter to drive the motors, and the existing loads of 20 kilowatt AC loads available in any electric vehicle will be controlled again by inverters, and motor controlling units are powered from DC-DC converters. Of course, any electric vehicles or transportation systems needs luxurious needs and production units which are controlled from 25 watt kilo capacity from DC to DC converters. If you look at these converters are very compact in size, maybe 10, the size can be 10 centimeter versus 5 centimeter in dimension, thanks to the innovation in silicon carbide and gallium nitride devices. So we have developed many electronics circuits from our lab, thanks to my researchers, past PhDs and postdoctoral researchers for their dedicated efforts. We developed an innovative solution which is based on industrial standards. If you look at the load side converter, which is a very standard boost converter. So the industries never want to change their mind from the existing business model because it's going successfully for them, irrespective of creating reactive energies or life cycle span, because they want to deploy their business inconsistent. So as researchers, we are focused towards providing some solutions for industries. We try to make an adaptation for the existing solutions. So we develop a new converter which is called triple mode active passive parallel interconnected converters, where we control on the front end side of the existing standard boost converter. So the output is always higher than the inputs. So we use a standard H bridge inverter where one of the MOSFET is replaced by the inductor L. And in the second leg, we introduce another inductor in parallel combination with the capacitors. What is the working principle? Is very simple. When the device is closed, we energize the inductor. Similarly, when the device MOSFET or IGBT is closed here, we energize the inductor. When the device is open, the inductors are not the energy storage devices, they are just instantaneous energy. The instantaneous energy available in the inductors will be delivered to the capacitor VC1 and the load side capacitor. So we get a very high voltage on the DC link which is connected to the existing boost converter. Then we produce high level margin. For laboratory testings and validations, we try to develop a DC microgrid levels around 400 volts, where we try to charge electric vehicles by using the electronics DC-DC converters integrated with photovoltaic systems. And of course, in the future, we are going to have more DC home application. Currently, our laptops, cell phones, iPads, etc., are powered by a small actuator, which is a DC to DC converter from our single phase main grid. Apart from that, we can able to integrate large scale wind turbines by using a two-stage conversion, AC to DC and DC to AC, and coupled to the DC microgrid by using AC-DC transmission. Then existing transmission lines can be integrated to the DC microgrid by using a standard thyristor model of back-to-back converter. You might be studied in your basics of electronics. Still, the thyristors are reliable devices for high power application integrating with DC applications. Apart from large storage battery devices can be integrated by using bidirectional converters which can convert AC and DC. During the peak demands, the stored energy available from the battery can be pumped back to the common grid. So in the future, the common grid will increase to 1200 volts to 1600 volts. Currently, we are working with 800 volts. For the testing levels, we used 400. And numerical model testings, we tried at a low power scale around 500 watts to know the efficiency of the systems, which is particularly good in numerical model, which is around 97%. But in the practical cases, it goes down to 93% because there are conductive losses, switching losses, and passive losses across the complete network, which includes digital processes. And these testings we are carried out not only for system level studies, but also for dynamic modeling and testing integrated with charges. For example, this is a simple solution which is available in the market, a boost converter. We also played on the load side by integrating simple passive components. So we call these modules as multiplier based on capacitor modules. So we integrate these modules in stages in series combination to increase the load requirement voltage to go to 400 or 1200 volt requirements. And these components are just made of capacitors and diodes. And these are tested at laboratory scales. You can have a size 140 millimeters versus 140 millimeters, very compact structures. Under faulty condition, it can be easily replaced all the components or complete unit, and tested with a high-speed FPGA solution with standardized gate drivers. And once the converter is be designed, we also look for dynamic responses. So the dynamic response is very important because in driving units, we go for slow speed, high speed, consistent braking applications. When you apply the brakes, the regenerative energy will come from your motors towards the battery. So these are different aspects in the dynamics of electric vehicles. So that's why we go for more dynamic approach. We try to regulate the load side, and we find the battery voltages are within the limitations. You can have a look here. The load voltage is maintained around 400 volt, but in real time it is around 394 to 96 because of the different losses. And the load currents are regulated according to the load demands. All the cases we are looking very closely the DC bus voltages, which are directly linked to the batteries and renewables. And the ripple content, we say the fluctuations are within the limits according to the IEEE standard, less than 5%. But our goal is always to keep 1% because batteries are highly sensitive. All the cases, our experimental results are well effective and matches the industrial requirements. And these developments are already addressed in IEEE transactions on industrial electronics. As a part of commercializations, we already made a pattern in United States on developing these new technologies for industrial aspects of existing boost converters to enhance their capacity. As I said, a number of legs are extended based on simple combinations of passive components of inductors and capacitors. and this has been made in 2021. So beyond the aspects of testings, we also look very closer dynamics of capacitors, because capacitors are highly reliable, cannot be highly reliable in real-time testings or applications, because they are very sensitive for small fluctuations in voltages and current. They can easily blow off. So there are different aspects of research is going in capacitors reliability testings in various research units in power electronics research. In this case, we try to understand the capacitors reliabilities and executing with proper modulations. You can have a look. The voltages of the capacitors in real time are regulated in symmetrical fashions because we use more capacitors, and there are no short spikes or any asymmetrical operation which can easily affect the renewable which are connected, particularly fuel cells and batteries on the input side. All the cases, the voltage, the current through the inductors are periodic. You can have a look, and there is no any huge perturbations. And we try to do these model testings in a different scale, because to know the dynamics, we used different model power scales: 500 watts capacity, 600 watt capacity, high capacities, etc. All the cases, the numerical models are really matches with the real-time applications. In numerical model, we are exactly near to 400 volts because they are ideal conditions. But in practical cases, we are reaching near to 394 to 96 volts after compensating various losses. So we try to do all these in a dynamic simulation models. You can have a look. All the capacitor voltages are more able to produce a DC, but in real time there are little fluctuation. This is obviously happen with the dynamics of the capacitors and its design. All the cases we are able to maintain the standards, requirements, and limited ripple activations on the input side as well as on the output side of the propagation systems. Of course, we have developed other power electronics converter. With a limited time, I can't discuss more on this. So this is another module where we try to integrate on the input side by introducing the half bridge converters, where one of the MOSFET is replaced by the inductor X, another inductor is replaced by Y. The idea is the same. We energize the inductor LX, energize the inductor LY by closing the device. When the device is open, all the energy will be transmitted to CX from X and CY to Y, and we add up these capacitors in the form of parallel combinations, so that the input voltage on the load side boost converter is developed to a very high level. And we compared with the existing solutions in the market as well as the solution available in the literatures. We find around 60% of utilization of fuel cells and batteries. We got again more than 42 times. The application is focused to integrating the fuel cell technologies, batteries, and photovoltaic plants to a common point of coupling to pump to 400 to 800 volts for electric vehicles or DC microgrids or DC home applications. Once we design the converter, the most important is the distribution of losses. So the MOSFETs provides a losses between 17 to 16 percentage, diodes between 5 to 4.8 percentage, 5 is the max, and the capacitor which is around 6 percentage losses, and the inductors providing 9 percentage losses. So we know all the distribution before deploying into real-time testings. In real-time testings, we are coming near to 400 volts, but not exactly 4. As I said, 395. And the voltage across the diodes ensures that they are in forward bias condition. One of the important aspects of our application are that during the reverse bias or any fault occurs, the input is well protected because there won't be any path for reverse flow of current towards the supply. And these are the device voltages for the MOSFETs, which shows the pumping the voltage from battery level from 48 volt or 24 volt to 185 volt, which is pretty high. And these are the currents through the inductors we always monitor, because these inductors are directly connected to the renewables, which includes batteries and fuel cells. So their symmetricity is very important for us, as well as the fluctuations that can easily damage the batteries and fuel cells. As I said, in the real time, we are not getting exactly 400 due to the various losses. We are coming very near to 395.2 volts, near to the common point of coupling DC microgrid voltage. And we pump back to 206 in a symmetrical scale of design. All the cases, the current through the inductors are symmetrical, smooth propagations, no spikes, that can well effectively controls the renewables by keeping the battery margin around 30 volts stable conditions. And these are the dynamic results. You can have a look how periodically we regulated the loads, whereas the input is never been affected. and the load current follows exactly the load requirement with respect to the input current. And this is the configuration we develop in the laboratory scale. You can have a look comparing to the big scale of testing modules. The power electronics converter size is only 150 millimeter versus 150 millimeters. With advanced gate controls we used to test for high quality results. And with these applications, we have developed many power electronics converter from our lab, which includes switched capacitors, switch inductors, multi-level converters, and XY family. We compared with the advanced solution, which is transformer-based solutions, which is highly in demand for wireless charging, etc. So what is the disadvantage for the advanced solution is the reliability is average. The cost is very high because they use high frequency transformers and design is complicated and high efficient. And of course, advantage, we can able to have high power, soft switching, reducing the losses. But other losses will come into the picture, which is magnetic losses, which is bulky in structure, and it can be adapted only for heavy duty vehicle. But what are the configuration we developed based on switch capacitor? It can be used for low power application. Switched inductor based configuration, it can be used for low power application. Multi-level converter, what we developed, can be adapted for heavy duty application. In overall scenario, based on the requirements, what we developed XY family can be used for both low power as well as high power application. The most important thing, we have used only one or two MOSFET switches or IGBTs. Particularly in XY family, we use only one device, only one MOSFET and one IGBT, so that the reliability is very high and the cost is very average and efficiency is very effective. And but what is the disadvantage? We use more diodes, which can create discontinuous mode of operations. One of the disadvantage. But I didn't present you more detail because with the limited time, I can't able to go inside application. Next part of our applications, we are working more on AI technologies, particularly to optimize all the renewables connected to the grid. I want to show you some examples how we are working with hybrid renewable energy system integrated with power electronics converters to enhance high power application with the grid. And this application we are focused towards centrifugal pump, particularly towards agricultural aspects. So we integrated photovoltaic panels, wind turbines, particularly by using permanent magnet synchronous generators, then integrated with our own developments. I showed you some example. We also developed cuck converters, which can able to enhance the DC power capacities. And we use photovoltaic panels again by using cuck converters, which is a high power DC to DC converter. All are integrated on the common point of a DC link with the existing inverter. And we also use battery banks. So in this case, we have hybrid renewables, wind turbine, photovoltaics, and backup storage as a battery. So when the renewables are increasing, the power scale is increasing, and the dynamic control become very complex. So in this case, we use different artificial intelligence algorithms which we develop. So for example, to control the maximum power point from the wind turbine, we use our own algorithm called ABC, which is and called bee colony algorithms. We develop new constraints, optimized algorithms with limited iterations. For example, in case of power system application, the researchers will be using millions of data to analyze with MATLAB, but that is not possible in real-time scenarios with digital signal processing equipments. So we use like say 50 to 60 hydration systems, only data, which are very crucial for the power system to control the effective pumping of the induction motor drive. Then we use particle swarm optimization techniques where we adapted new algorithms, new constraints to enhance the capacity of the inverter. In case of photovoltaic systems, we used again the particle swarm optimization algorithm. So all different AI algorithm we brought into one set of applications where each algorithm will focus on particular aspects and governs the system for effective power flow. For example, as I said, we use only 50 hydration to establish our requirement for the goal, and the runtime is only 15 seconds. And the desired cost function, the error is only 10 power minus 6. So you can have an idea how much limited data we used. And the number of constraint required for the hydration of the B is 10. Number of on-locker B also we kept 10. It's very small size. We start the program, we feed all these parameters into the systems, then we calculated the required duty cycle to control the inverter for the induction motor drives. Finally, we calculated also the fitness function based on the equations that you can find in our reference papers. Then we try to update the duty cycle for the cuck converters and new inverters based on the feedback get from the induction motor drive. What are the feedback? Speed, current, and voltages. So these three parameters we sense by using sensors, and we do the calculations in the D space along with the MATLAB program, which is a co-simulation module, and try to figure out the optimal value of duty cycles. And these iterations are fixed, as I said, only in 50 cycles. Once the 50 cycle is done, we get the optimal value to terminate the program. This is in order to show you some example. I don't want to go for a very complex system. A simple example is the V by F control, where we control the speed of the induction drive, sensing the speed of the rotor.
Professor Sanjeevi, can request that can you please conclude in 5 minutes?
Is possible. Yes, thank you. So we sense the speed and we given to the artificial intelligence controller, which controls like a PI regulator. Then we make a V by F control to control effectively the modules. You can have a look how we are controlling the speeds very effectively with huge oscillations from photovoltaics and fuel cells. The quality of the waveform we produce are very high quality with the reduced distortions. You can have a look here how much distortions are much reduced with different scales. I like to conclude with small results. You can have a look the total harmonic distortion which are produced in the currents and the voltages are limited less than 5%, even though there is a huge perturbations available from the photovoltaic and fuel cells, and unity power factor is maintained on the grid side. And like to conclude my presentation, we are using more fuel cell technologies integrated with the grid with the low cost fuel cells and integrating with microgrids. As I said, we are not using lead acid because the technology is gone away. Lithium ion batteries are currently used, but these are very expensive with limited lifespan. So we have to look for other possible solutions, which include supercapacitors. But integrating all these renewables, there is a big problem with voltage instabilities, harmonics, voltage sags. So we need to go for modern AI-based technologies based on smart grid. In the future, we will have more vehicle to grid, grid to vehicle, home to grid, and grid to home technologies by using smart meters, by using IoT sensors, and integrating for the system penetrations. These are the big gaps in the research available before us, and many researchers can work on hybrid AI algorithms which can able to be more precise and faster executing the velocities, and of course they are self-recovery and resilience by using modern devices of IoT. Thank you very much for the invitation. If you have any question, I'm happy to respond.
Hello, Dr. Sanjeevi. Thank you very much for giving very informative talk. And due to the paucity of time, we ask you to conclude in 5 minutes, but it was very informative talk. I have just one query that is coming in my mind, that there is a concept of coupled inverter based converters. So people are talking about these improvement. So can you comment on this, that what is the use of this for the EV and the renewable energy for that?
As I said in my summary, we are comparing all these technologies with the coupled converter, which is a resonant version. I showed you a comparison. Here you can have a look. For a wireless technology, currently I'm working with IIT Delhi, a startup company called Dash Dynamics. They are in the IIT campus. So we are working for Adani projects in Gujarat for deployment of wireless charging network in the airport. So these converters are widely used, but the technology is still questionable with coupled converters because of the designing the wireless transmitter and receivers and making the distance much higher is very, very complex. So we have produced some solutions based on non-coupled version or a non-isolated version. As I explained in my presentations, we have 4 different configurations. The 4 different configurations can be adapted either respective of low power or high power application. The most complexity in designing the coupled converter is designing the high frequency transformers and to avoid the losses in the magnetic coupling. So these challenges are still, but many researches are going on, and I think if we find an optimal solution for designing these transmitter and receivers, I think it can be highly deployed in EVs.
Okay, so thank you for commenting this. Thank you. Yes.
Thank you, Dr. Padmanabhan, for enriching us with your perspectives.
With this, we conclude plenary session 1. On behalf of the organizers, I extend a heartfelt gratitude to all our esteemed keynote speakers for their time, effort, and wisdom. A special thanks to our faculty coordinator, Dr. V.K. Tayal sir, for his constant guidance. To all participants, thank you for being part of this session with such enthusiasm. Wisdom is not a product of schooling, but of the lifelong attempt to acquire it. Let us carry forward the ideas sparked here into our research and innovations. Thank you.
Thank you very much for the invitation to Amity University and Professor Tiwari. Have a great day. Bye. Thank you very much.
I request IT team to please close the session. Thank
Good afternoon, everyone. Welcome to plenary session 2 of RDCAPE 2025. This session focuses on intelligent data analytics, smarter grids, and robotics. The beautiful thing about learning is that no one can take it away from you. Joining us for the second plenary session are three distinguished speakers. First, Dr. Hasmat Malik from University Technology, Malaysia. Second, we have Dr. Deepti Srinivasan from the National University of Singapore. And third, we have Professor Dr. Stephen L. Smith from the University of Waterloo, Canada. We are delighted to welcome them, and without further delay, let us begin with our first keynote speaker.
Our first keynote speaker is Dr. Hasmat Malik, professor at University Technology Malaysia, a senior member of IEEE and an established researcher in electrical power systems. His work focuses on smart grids, reliability, and sustainable energy solutions. He will present on tools and techniques for intelligent data analytics of renewable energy resources.
Dr. Malik, the floor is yours.
Thank you. I hope I am audible to you.
Yes, Dr. Hasmat, I am Dr. Tiwari speaking this side, and you are fully audible. Welcome.
Thank you, sir. Thank you. Just please allow me to share my screen.
Yes. Yes, it is visible. We can see your presentation.
Okay, sir, may I request you just for 5 minutes, just introduction of my organization?
Sure.
Is it possible?
Yes, please.
Okay. So actually, generally we introduce our organization because of so that other participant, maybe new researcher, may get benefit from our side if they are needed.
Yes, please do.
Thank you, sir. Thank you. So I am associated currently with the University Technology Malaysia. So University Technology Malaysia is a quite reputed and old prestigious university which was started in 1904, and on the time name was Technical School, but the actual name, like as currently we can see, University of Malaysia government renamed in 1975. We have 12 different faculties. Each faculty has like a different department. In the reputation wise, we are 153 in QS ranking, and in Asia 28th number. So as of now, we have 3 main campus located in Malaysia. So like main administrative and main campus located in Johor Bahru, which is quite near to the Singapore. And another campus we have in Kuala Lumpur, capital city of Malaysia. And third campus in Pago. Pago is another industrial hub, kind of industrial city of Malaysia. So this is like a very big and beautiful campus, main campus located near to Singapore, more than 1,100 acre. Recently, few years before, government also allotted new land. So if like any researcher wants to visit, it's a quite beautiful campus and huge in term of area and beauty. So like traveling from one corner to another corner, maybe 15 to 20 minute drive we need. I am belonging to the Department of Electrical Power Engineering, which is a one department among of other department in the Faculty of Electrical Engineering. So which is located over here. And in term of the like a collaboration throughout the world, like in term of memorandum of MOU, MOA, and LOC, and industry partnership, we have huge number. So like industry collaboration, we have more than 700, MOA more than 400, MOU throughout the globe more than 500, and letter of LOC more than 200 letter of collaboration. So here, this is like a brief journey of my faculty, which is called Faculty of Electrical Engineering. So in the beginning, it was known as a Faculty of Electrical Engineering, and it started in 1974. And the government, according to the policy, they changed the name, renamed the different version. So previously it was called School of Electrical Engineering, but recently again government revert back and gave the name, same like in the beginning, Faculty of Electrical Engineering in 2022. So here, it is like a brief information of Faculty of Electrical Engineering. So we have 5 different departments within this faculty, 22 centers, different research group, 16 academic program we float here, starting from the undergraduate, postgraduate, and doctorate. So here, like a master course, we have 3 different categories. One category, master by taught course, like master will be completed by securing some credit through the subject as well as project. Another category is master by research. So this is totally depends on research, similar like master of philosophy in our Indian scenario. And another, recently we started master by professional. So it is purely for industry people who has a professional experience, extensive experience. So it is like a ODL kind of scenario, open distance learning. In terms of the student, we have more than 27% of international students, and these international students are from different countries. In terms of the supporting staff, we have 90 supporting staff, and academic staff, we have more than 200. So here 198 statics is until last year. So this year in faculty recruited several more. And in terms of total staff, like academic and non-academic and supporting, more than 500 staff within this faculty. So we are like a biggest faculty of UTM as of now. So here, this is the like a brief information so about the faculty. So if we have different research center with different facility, center level as well as individual department level. So we are very happy to support any organization in term of the research and in term of the any event. So this is like a brief information, and good thing is like at the university level we have like a, this is kind of agenda so that we can provide the information to everyone where we can do, and so that other can get benefit from our resources as of now we have. So regarding the today topic, tool and techniques for the intelligent data analytics for renewable resources. Before starting the discussion, I always request all participants, no need to consider this like an expert lecture, because this is my side assumption. Like normally in expert lecture, like it is like a one side delivery. So consider it is like a discussion, so that it should not be binary one side delivery. It should be like a both side interaction. So regarding the intelligent data analytics, it is like not a new things. As well as renewable energy resources, these are also not a new things. But before going in detailed discussion, we can see one big question here. Like until 2018 in this world, there was some kind of challenge, like which type of the resources should be known as renewable energy resources. So according to that definition, everyone or most of the researchers who are working in this domain can follow the guideline. So for this point of view, like to discuss like which resources is known as renewable energy resources, there was a roundtable conference in 2018 in the Sydney Law School of Sydney. And good thing was more than 115 participants from the different nations. So meaning is more than 150 nations representative were there. And the good outcome from that roundtable discussion was that more than 113 country has a their national energy law, and 138 country had a support policy. India is one of them. And more than 146 country had a renewable energy target, like we have renewable energy target. And the representative of each nation provided like a different type of information in term of policy, in term of regulation, in term of like a 5-year plan, long-term plan, short-term plan, and application of renewable energy in term of commercial and domestic. And based on the provided information of the representative of different nations, the whole roundtable conference came at the conclusion like there is no single resource that can be decided or can be defined, okay, this is only renewable energy resources. So they came in term of the prioritization number. And in that prioritization number, they found that wind resource has a highest priority number, and followed by solar, photovoltaic, concentrated thermal, and hydro, and so on. So based on this prioritization number, here I tried to do some data analytics only for wind and solar. And if we will see here in terms of the renewable energy generation as well as consumption. So we can see few statistics like here starting from 1965 to 2020. Why only 2020? Because during that time, like a pandemic scenario, so that's why I exclude the data during the pandemic. And I try to show some interesting statistics here only for one decade, 2010 to 2020. And we can see here very interesting figure. In 2010, the generation of the renewable in terms of as a renewable energy from the hydropower was more than 81%. And wind was around 8% and solar was less than 1%, which is represented blue color. And if we will see the statistics in 2020, it is quite interesting scenario going to change here. We can see hydro drop from 81 to 57. So it is a quite interesting changeover within the renewable energy generation. And this drastic change from the hydro covered by means anyhow we need to balance out the energy demand. So most of the part balance out by the wind. And we can see here like in 2010, wind was as a commercial application only around 8%, but in 2020, it is more than 21%. So roughly we can see 3 times enhancement in the wind application. And the another interesting part we can see here in terms of solar. In 2010, commercial application was less than 1%, but here we can see around 11.5%. So it is also a very quite interesting change over here in terms of the generation. And if we will see statistics starting from the 1965 to until now, we can see here 1965 wind and solar application was 0 as a commercial, and going on decade by decade. And if we will see here like a 2020, data. So 2020, the commercial application of wind out of 7,444 terawatt hour, 1,591 from wind and solar 856. And the current scenario we will see last 2023, we can see together wind and solar almost equivalent to the hydropower, which are the like a biggest player of the generation of the every nation. Similarly, we can see here in terms of the consumption, the primarily consumption managed by the gray energy, which is coming through the like a coal based energy, and rest part next next highest part is hydropower, and there is a wind and solar. What we can see here scenario starting from the 1965 to until 2000, we can see it is increasing gradually like a decade by decade, but in 2000 onward we can see the utilization of the gray energy going to down, declination. So meaning is this declination meet by the another alternative resources like a hydro, wind and solar. So we can see here how the consumption is increasing, enhancing decade by decade. And if we will see like a very simple statistics, like a global power share handling by the gray energy and by the renewable energy, and we can see in 2000, so in 2000 most of part managed by the gray and very minimal part managed by the provided by the renewable resources as a commercial application. But here in 2018, it is a quite interesting statistics like gray from maximum part to reduce to minimum part around 35%, and renewable increased up to 65%. So maybe in future renewable may take over the gray in term of like a more than 80%. And this is like a very surprising statistics. Few part of the world like a Vietnam, renewable has a like a big player as compared to the gray energy. California, like several different country in the world's available that they have highest generation of renewable energy. So for the focusing this idea like how renewable is increasing, then here I try to find some interesting information in terms of the state of art, and this state of art really very surprising for us. So this state of art cover two category. One is IP status, another is scholarly work like a blue sky research or maybe publication. So if we see here IP status, normally we perform lens.org or PetSnap. So here lens.org is freely accessible website, PetSnap subscription based. I use PetSnap and it will give more authenticated data, and I really find very interesting information starting 2006 to 2016. And we can see like including all renewable energy resources, doesn't matter which has least of prioritization and the highest prioritization number according to the definition by the Sydney Law School roundtable conference. So here we can see very interesting statistics like in the globe in 2006 the total number of application filed 22,000 sorry, and these 22,000 increasing year by year. So in 2006 22,000 around, but next year 2007 50,000 plus, so approximate 2.5 times more. And here we can see increasing year by year. In 2016 number of applications around 500,000. So meaning is like lot of researchers are trying to do work in this domain to secure the IPs and try to support their nation. And according to the statistics, it is a very surprising thing, like in terms of the securing the commercialization, like a IP, we can see here statistics from the Indian region. So in 2006, around 15, but in 2016, 1,400. But here, interesting things, most of IP filed around 90,000 only from one country, USA. But the other, another good thing here, like in terms of the resources, we are like a top, we are a big player as an Indian nation. We lie in top 5. But in terms of the commercialization security, commercialization support to our nation, we are very lag behind. So being a researcher or being an academician, here we need to think how can we support to our nation by securing some IP. Because doesn't matter how much percentage support will be counted to the nation enhancement, but it is like a kind of support if we will try to secure some IP. So it will give some kind of benefit to our nation. So here we need to think as a researcher, we should do such a kind of work so that we are able to secure some IP for us, and that IP will support to our nation indirectly. And if we will see here, few statistics belongs to few like a major player within our Indian region, we can see like a number of IPs are very negligible. So here we can see hydro, 2016 no filing, but 2015 a lot. Wind energy, very less. Wind power, 397, but in 16, negligible. PV thermal, solar photovoltaic, solar thermal, like that we can see these are very negligible number of the statistics. So here we need to support, we need to think so that we can support our nation by securing some IP. Other than this state of art, I try to find some interesting result through the in term of the publication, and these publication cover only Web of Science publication, only belongs to the two keywords like solar forecasting and wind energy or wind power forecasting. And it is a quite interesting result within a Web of Science listed paper in 2001, around 50 paper. But year by year, we can see here increasing. And we find here like a quite interesting scenario in 2020 and 22 and 23, like wind reaching around 550, solar reaching around more than 200. So meaning is like research throughout the world in this domain is increasing, enhancing day by day. So sometime being a researcher, I always think, oh, it means this is not a new research area. It is a well mature area. So how can I start my research? Because here lot of IPs, if we will see the statistics of IP here, we can see 2016, but in 2025 maybe it will reach more than 1 million. So in terms of publication, a lot of publication. So then as a researcher, I need to think, how can I do my research in this domain? So yes, this is a well mature area, but there is some kind of bottleneck that will provide us some kind of research gap. That gap we can harness as an benefit, like, and what kind of the research? Like development of new models, alternative models, that models are maybe able to perform with higher accuracy. This is the one alternative area. Another area in terms of the application. So we need to do some kind of research in terms of model development and in terms of application solution. So now as a researcher, I always think, okay, how can I develop model? In which domain I can develop model? Because renewable energy resource is quite vast. So means doing research in this domain look like a jump into the sea and try to find a corner. So here I try to list down few important research area with my research team, and here we can see 7 broadly categorized area. These area, like any new researcher, or we can start as a doing research. So like first area is early stage mapping and visualization. Second area, generator performance and modeling. Third, technical potential analysis. Fourth, supply curve modeling. And fifth, economic potential analysis. And sixth, capacity expansion, and followed by like a production cost modeling. Now, second question came in my mind as a researcher, like which area I should select? Because, okay, these are the 7 area. So out of these 7 area, which area I should start? Because let's suppose I am a beginner. I am a beginner researcher. I started my research just recently, so I don't have enough time to explore, and also I don't have enough expertise. So to select this area, here I try to show some block representation. X-axis, this represents like a volume of the data required to solve this type of problem. Y-axis represents like a complexity level of this problem. So one square box means required minimum amount of volume. So number of square means increasing amount of the volume of the data. So like category 1, early stage mapping and visualization, needs less amount of the data. But it is also very simple kind of problem. If we will start our research, second category, generator performance modeling, that means we need like a 4 times of the data as compared to first category. So meaning is here complexity level little bit higher. And similarly, third category, technical potential analysis, more volume of the data required, but still like a more complexity is increasing. So here, if we will see one by one, like a top 7th number, production cost analysis, it required again less amount of the volume, but it is a more complex problem. So as a new researcher, I always suggest like do not start this category of the problem, because this is like a complete like a city level study. So let's suppose I need to plan something for 5-year plan, 10-year plan for a city level, like in New Delhi level or Greater Noida level, or maybe country level. Then this type of problem I need to study. So to study this type of problem, production cost analysis, meaning is I must have expert skill before this problem, all 6 category of the modeling and analysis. So, like in simplest way, any researcher, those who are beginner can start at this first category of the problem. Now, I have research area as a beginner. Now, I have some idea, like a high level of brief idea, like how can I select area out of 7 for my problem. Although any area can be selected in the beginning, no problem, but need some understanding, some learning, and the duration of the learning depends on the researcher capability, how fast they will grasp the information. Now, third question came in my mind, being a researcher, how can I do this type of modeling? Because for doing modeling, I need some kind of software platform. And generally, the software platform expensive and leads to finance. And because Sometimes because of limitation of fund, sometimes some guideline and regulation, I cannot explore the available facility with other university. So there are so many reasons. So now, and third point here, like which type of software, so that whatever model I will develop, industry people consider my research. Industry people can also willing to adopt my solution. So meaning is I must have some kind of software platform that will be available for me, and also that platform will be recognized by the industry people, especially in this research domain. So from where I can find to solve this type of the question, my research team tried to list down few software here, and these software are not only utilized by the industry, are also being utilized by the industry. And meaning is, these are like a list of the software utilized by industry, and industry validate their model before going to actual installation on site. So like for category 1, simple mapping and visualization, here we can see Arena, Lawrence Berkeley, and Renewable Energy Data Explorer. So many 5 different software platforms. Any software we can use. Yes, sometime this software cannot be downloaded, cannot be explored directly because of some restriction. But if we will request through our official email, definitely for academic purpose, these all are freely accessible. So for category 2, generator performance modeling, here we can see the 4 different software we list down here. For third category, 3 software we list down here. For category, next category, supply curve modeling, 2 software we list down here. And economic potential analysis, 2 software we list down here. Capacity expansion modeling, 3 software we list down here. And last, production cost modeling. This is like a type of problem like cannot be solved by single software. It always works with the multiple parallel processing of multiple software platform. So we can see here 2 software here. So all software freely available, but sometime few software needs like a request through your official email ID for the academic purpose. They definitely allow, not a problem. So now first question was to find the research area. Being a researcher, new researcher, we have now solution. We have 7 research area. Second question was, how can I select research area? So here we can select according to this simple analogy. Third question, as a being a researcher, I had like a what type of the software I can use to develop this kind of model, so that industry people can also like to adopt my solution, and they can also support to me. So this question also solved. Now, as a researcher, another question came in my mind, like how can I validate this model? This is the next challenge. And for the validation, I need some kind of that data, like a sensor data or maybe measured data from the on-site. To solve this problem, my team tried to club some few digital library which are available freely for the academic purpose. We can download the data over here. And especially here we can see like a dark brown color. These are the image based data. If somebody try to do work using image, so we have here image based data too. So, and apart of these 26 library, another my researcher developed the data library for 192 country. So he tried to show how can we download the data, especially for wind and solar, from different location if we are not able to collect the data from the meteorological department. So this is a kind of alternative approach here for 192 country. So now this is the like a main 4 question being a researcher I had, and now these are the solution. And in terms of the data, it is a quite interesting result. Based on this data library, we found like around 47% data only available for the like a purpose of accessibility, real side data. Rest 53% data mostly not available for the application purpose because of certain limit and reason, maybe some kind of security reason, of course, will be very concerning things over here. But this 53% data we can download by using some alternative way. And here we can see few important data library. These data library can provide the data for different reason without any financial obligation. Especially for India, like I will take one example as in India. So in India, around 2016 or 17, we had 448 stations throughout the Indian nation to record the data. And on the time, the whole data freely available. This was the good opportunity for the researcher. But now, because of some security and some reason, now data cannot be downloaded freely. But if we will request as an academic purpose, we can get the data from the our MNRE website free of cost. But even though, let's suppose I am a beginner, I am not able to access the data, even though I try to request, there is some alternative 8 different digital domain we can use to access data for any part of the our region. Here, these are the one of out of 8, one of the important data library can provide the data like a single point, multiple point per hour data, daily basis data, monthly data, annual data, and very simple to use. We can download the data. Another digital library, here we can download 3 different type of the data like solar PV performance data, actual PV model, whatever available, different part of the globe, solar radiation data, and meteorological data. So these data can also be downloaded using this platform over here. So this is like a quite a interesting scenario right now throughout the world. We are not dependent to anyone. Right now, throughout the world, like our Indian government are also providing lot of support indirectly to the academician. As similarly, other nations are also providing lot of support indirectly to the academician. But the thing is, how can we use that support? How can we utilize that resources? So we need some kind of awareness, some kind of motivation too. So here, now next part is now I had a 5 question, so all 5 question now almost covered being a researcher. Now last point is here, how to develop machine learning or data driven algorithm. I will not go here in depth. I try to show you information here like a beginner point of view. How can I select algorithm? Which algorithm is suitable for my problem? So normally machine learning algorithms are into 2 categories. One is supervised, another is unsupervised. And here, for the beginner point of view, those who are expert, no problem. But for beginner point of view, I need to check my data. Normally, data has a 2 category of the data set. One, data set has some input variable corresponding that input attribute has also target value. Maybe other category of the data only have input variable either or only have output variable either. So we have these type of the data. So let's suppose category 1, if I have data input variable corresponding to the target value, I can select supervised learning. If I have only target value, either one category of the attribute, let's suppose target value, I can select unsupervised learning. But after getting some kind of expert skill after few time of interval, then the expert candidate can use any learning algorithm for any kind of the data. But for the beginner point of view, better is for input corresponding to target, use supervised learning. And this is like a very interesting problem, live problem. I solved this problem during in 2019 to 2021. So around around more than 2 years I used to solve this problem. And here from this problem, I always try to motivate everyone, like especially new researcher, don't think too much complex problem. Try to solve very simple problem. And try to solve that simple problem in a simple manner. And definitely we will secure the IP as well as we will secure good publication from that idea. So this is like a simple problem. Problem was like in commercial building or maybe theater. Okay, we normally feel like a centralized air con system is there that will provide the cool air to the inside environment of the building or maybe inside the theater. And normally if we have a like a experience, all of us had an experience like a going theater, watch a movie. And when we enter the inside the theater, we notice, oh, outside is very hot, inside very normal and cool. But after sitting over there 15 or 20 minutes, then we will feel some kind of shivering, right? And this is because of inside theater, the air con providing cool air is not self-regulating. It is manually regulating. And manual regulating means operator change the temperature of air con. And generally temperature never be changed by the operator. He will fix like 18 degree or 20 degree once in the morning and then it will be continuously. But sometime in theater, house full. Sometime theater is empty. Very few number of the audience and candidates, those who are watching the movie. So if house full, no problem. Full means lot of sitting area and lot of human heat generated. So no problem. But if few people means no need too much low temperature. Low temperature means high energy consumption. So these things to make it self-regulating will be depend normally two category of the data. One, inside building data, that is called controllable data like temperature, humidity, ventilation, airflow. Another category of the data is uncontrollable data.
Very sorry to interrupt you, sir. Due to the time constraint, please conclude.
Oh, sure. Okay. Thank you for information. So now question is, these data can be controlled easily, but uncontrollable data cannot be controlled. So here, using the machine learning, I try to predict and forecast all these uncontrollable data and forecasted value per minute, per hour, per day, per like that way, according to the weather situation like sunny day, cloudy day, rainy day, heavy rainy day, we set the schedule of the operation of this air. automatically rescheduling. And based on this simple problem, my organization, previously I was with UCB Berkeley, University California Berkeley. So my university is able to secure BPO. BPO, first they apply for US patent and then convert it into BPO. And they almost cover these all nations. So this is like a simple problem, simple solution, and they are able to secure these things. So my here advice is like try to think very simple way, try to solve in very simple way, and the outcome will be very high level. So I will conclude here. I stop my presentation here. Okay. So sorry, I think I use a lot of extra time. So thank you. If any question, please feel free, and you can send me question, WhatsApp or maybe email. You can reach out anyway, and I try to, or not I, with my other colleague, we are here very happy to support anyone without any intention. Maybe like if anybody need help in model development learning or simulation learning, data handling learning, or maybe any out of these, any research part, how can they solve their problem? We all are here to support them, and we are very happy to support.
Yes.
So thank you, everyone. Thank you, all of you.
Thank you, Dr. Hasmat, for giving very informative talk. And you couldn't see it, but I was seeing it here that many of the students and the participants were taking the click of your slide because it was full of information. The link that you have shared, that from where we can get the data related to RES, that was very informative. So thank you for sparing time and joining, because we are moving towards the sustainable world, and RES is going to play a very critical and vital role. And if we are going for doing the prediction analysis and these all the things for the forecasting, data is going to play a very big role, and data analytics is the one part of that. So thank you for sparing time, and I will be collecting the questions if there will be any, and will be forwarding to you, and looking forward to work with you with a more collaborative work. And thank you very much.
Thank you, sir. Thank you.
Thank you.
Thank you, Dr. Malik, for such an insightful session.
Our second keynote speaker is Dr. Dipti Srinivasan, professor in the Department of Electrical and Computer Engineering at the National University of Singapore and director of the Center for Green Energy Management and Smart Grid, a fellow of IEEE. She is an internationally recognized expert in smart grids, renewable energy, and computational intelligence, with over 400 publications. She was honored with the IEEE PES Wanda Redder Pioneer in Power Award in 2022. She will present her talk on tackling uncertainty, how data and deep learning are powering smarter grids.
Ma'am, the floor is yours.
Thank you so much. I really appreciate the invitation to speak at this prestigious conference. Let me just get my slide. Just one moment. Are you all able to see my slide? Just wanted to check if you could see my slide.
Just you need to put into the slideshow mode.
Yeah,
Earlier it was.
Okay, I need to check.
Yes.
It's okay now?
Yes, it's okay.
Okay. So I know that we are probably running a little late. I'll try to wrap up my lecture in about 30 minutes or so. So today I'm going to talk about tackling uncertainty and how data and deep learning are powering smart grids. And Prof. Malik has provided an excellent introduction to my talk. So I'm going to focus on some of the specific case studies and so on. So the uncertainty associated with the growing share of renewable energy is increasing as we have more and more renewable energy sources integrated in our grids. And I'm going to talk about what are the challenges and why we need a data-driven grid management, which is also smarter. How can we leverage AI techniques? And I'm going to discuss this from the point of view of some of the case studies that are based on the work that we have done in Singapore as well as in China in collaboration with our partners in the industry. As we all know, the global share of renewable energy has been increasing at a very rapid rate. And we can see from this figure on the left how in the last 10 years, the share of renewables has been increasing. By end of 2024, it had reached a record-breaking 585 gigawatts, which was the largest absolute increase over the previous years. And the share of renewables in the primary energy consumption has already reached 19.6%, which is great for the environment. But I'm going to talk about what are the challenges that this kind of large integration poses to our grids. Now, the greater integration of renewables has also been facilitated by various initiatives around the world. For example, in EU, this very rapid renewable energy deployment and this already huge amounts of renewables, which has led to 40% upward revision in the capacity additions. In the US, this year, of course, is not so good, but until recently, until the end of 2024, the Inflation Reduction Act significantly accelerated the expansion of renewable energy. China is the world leader. It's the undisputed world leader when it comes to renewable energy projects that they have and the pace of development. They have added nearly 3,700 gigawatts of new renewable capacity, and they are expected to keep on adding at this pace. And this will account for almost 60% of global new capacity. India is also emerging as the second growth country, especially in the recent years. Now, all of these highlight the importance of leveraging on data, because with all these developments, we also have some issues that we need to tackle. So let me just talk about how the uncertainty can be managed in smart grid and where is this uncertainty coming from. From the source, that is the renewable generation technique, we have a lot of uncertainty that needs to be captured. Similarly, we have from the demand from the users, the electrical demand also has a lot of uncertainty, which is growing very rapidly, especially when we have electrical vehicles in our mix. And then on the system side, the grid itself faces more uncertainty and unpredictability. So my talk will sort of focus first on uncertainty capturing in the generation, and then I'll talk a bit more about uncertainty in user demand, as well as how we can manage this uncertainty at the systems level. The uncertainty in smart grid and smart energy systems can be set to have, like from generation side, about 30% of global electricity generation that is coming from renewables. On the demand side, what is happening is that as more and more renewables are integrated and we have more and more virtual power plants, we have more electric vehicles, the user demand has changed. And how much of electricity then has to be generated by central power plants is also going to change, because the central power plants do not know what exactly is the demand, because the patterns of consumption have actually changed a lot. In fact, we now have a new term called prosumer, which refers to users which are also able to produce electricity. For example, it could be a factory that has renewable solar PV panels on the rooftop. They're able to generate electricity and sell it to the grid, but they also consume electricity. Similarly, if there's a large car park at a workplace, which has a lot of electric vehicles, when they come and park at the workplace, they have electricity that is stored in their batteries of the electric vehicles. They can sell this electricity to the grid, and this kind of electricity storage becomes really crucial from stability and reserve requirement point of view. And this also means that not only this entity is consuming electricity, taking in electricity from the grid, but it's also able to sell electricity to the grid. This dual role is encapsulated in the term prosumer. So the main point is that forecasting and managing uncertainties is becoming crucial. Now we can look at this entire landscape, but we can sort of summarize this into three simpler problems that we can deal with. On the generation side, we can just pose the question, how best can we capture the uncertainty of renewable energy generation? On the demand side, a simpler question that we can pose is, how can we capture the uncertainty on the demand side or the user side? And how can we extract the patterns of electricity consumption in various communities, whether it's residential, commercial, industrial, or some other user group? And then the third issue is the matching of generation and demand in presence of uncertainty. So data analytics, like Prof. Malik has also highlighted in the previous talk, is now becoming really important because it is able to make the capturing and managing uncertainties a lot more possible and effective. So in the data analytics side, things are actually improving a great deal because today we have the ability to collect a lot of data from smart meters as well as smart sensors, which was not possible until a few years ago. But recently, globally, we have huge deployment of smart meters. For example, United States has already reached 146 million installations by the end of 2024. Europe has many countries that have already achieved 80% coverage or even greater coverage of its smart meters. So we have a lot of data that is collected at every consumer's premises. Now, with the advent of 5G technology, we also have the ability to transmit that data that is collected and send to various data centers, the cloud, or entities where this data can be processed. So the introduction of 5G has now made it possible that we have much higher transmission rates, up to 10 Gbps, and we also have very high availability and very low latency, which was not possible until 3 years ago. So what I'm trying to say is that we have more data that is now coming from various sources. We also now have the ability to transmit that collected data to where it can process, as well as where it can be used for decision making in our grids. The data analytics process can be summarized in simple ways using this figure. So the first step would be the processing of data that is being collected. Second would be to do uncertainty analysis for that data. And the third would be to make sense out of it and use that data that is collected and has been processed with machine learning algorithms to make intelligent decisions. When we are using deep learning algorithms, a common framework for data analysis and decision making may look something like this. So we have a lot of data coming from power system equipment, from the users, smart meters, as well as we can have a lot of data coming from meteorological environment and other inputs. Now, all of this data is collected and then pre-processed. So before pre-processing can take place, we also have to prepare the data to suit the format in which the processing can take place. After that, the data is analyzed in a typical deep learning based algorithm. The machine learning algorithm will be running and coming up with some kind of a mathematical model, which can then be used for decision making. And I'm sure that all of you understand that most of these models have to be trained extensively offline. And then the trained model is directly used for decision making because the training time can be extremely large. So this mathematical model is then used to make decisions in real time. But it is running on this huge data analytics, processing, and deep learning framework, which makes it more intelligent and able to handle various kinds of uncertainties. So let me talk a little bit about some of the case studies in how we can capture the uncertainty in renewable generation. In Singapore, as well as in a lot of different areas around the world, solar systems are gaining a lot of popularity. We know that solar energy is free, and every minute, the sun is actually sending enough energy to the earth that actually can cover the energy demands for the entire world for 1 year. So every minute, we have a lot of solar power that is actually hitting our atmosphere. How much can we capture depends on a lot of things. But one of the interesting things is the variabilities during the daytime hours. So this figure over here shows how this data varies on a typical day in Singapore. From the hours between 8 a.m. to about 6 p.m., on a sunny day, you can have a very nice curve as shown by this yellow plot. But on a cloudy day, you can see a lot of variability. So we see that there's a lot of variation from hour to hour, minute to minute. So that's the temporal variability. But not only that, in many regions around the world, like in Singapore, we also have a lot of spatial variability or uncertainty. The map of Singapore is shown here in this figure, and different colors show how much is the irradiance that is falling on that part of Singapore. Singapore is a very small country, but we can see that even in a small geographical area, the variability in terms of space can be very, very huge. Now, managing this is important because it has impact on various operations in the power system from short term to long term. Similar kind of intermittency exists in wind power systems as well. This is a very famous figure. It's called the wind power flying spaghetti monster. On the x-axis, it shows the 24 hours of the day. Y-axis shows the power output from the power plant. And this is actually data collected from an actual power plant in United States. Every line that you see here is showing a different day of the month. So there are 31 lines representing 31 days of the month. What is interesting to note is the variability. From hour to hour, day to day, there's a lot of variation. However, if you take the average, you have a very nice, this blue line, which gives you the sense that there's a lot of predictability, but that's really not the case. And the high amount of variability that we see really affects the system operation. And this has to be managed, it has to be predicted to some level of accuracy, and that's what the challenge is. Now, machine learning is emerging as a very promising tool for forecasting of renewable energy, as well as for user demand, because it's able to leverage a large data set to identify hidden patterns and trends and use that to make better decisions. I'm going to talk about some of the work that we have done. This was in collaboration with our industry partner in China. And here I'm going to talk about how are we able to capture the uncertainty in solar PV power estimation. Before that, I also want to mention one more point. When it comes to forecasting, we are slowly moving from point forecasting, where, for example, one could predict that the power demand in Singapore at 10 a.m. tomorrow will be 9 megawatt. that is a point forecast because I'm forecasting a number, a specific number at a given time. We're actually moving away from that because that kind of a number does not capture uncertainty. We are moving towards a probabilistic form where the prediction could be that tomorrow at 10 a.m., the power demand will be between 8.5 to 9.5 megawatt, and I'm 90% sure about that. So that kind of prediction interval is very useful when we want to then make predictions as well as make decisions based on such uncertain future events. So that's the type of estimation that we use. So just to give you a bit of the context, in Singapore, we do not have any other renewable energy source other than solar. So the government is investing very heavily in building up the capacity. And we had a target of 1.5 gigawatt peak at the end of 2025, which we have already exceeded. By 2030, we are targeting 2 gigawatt peak of solar. However, if you look at the solar profile that I'm showing here on this figure, we see that even though we are expecting the solar PV panel to produce electricity as shown in the orange line, due to some unforeseeable reasons, such as bird droppings or leaves falling on top of the solar PV panels or some other kind of dust, the actual output is as shown in blue. So this means that this kind of soiling of solar PV panels can actually reduce the efficiency of the panels substantially. Even though using sophisticated models, we may have said that, well, despite the change in cloud movement, this orange curve is what I should be getting, but actually I'm getting a lot less. Now, how do we work with this? And so this was also a problem faced by this Chinese collaborator and industry in southern China that actually came to us, and we have worked on this particular model development with them. So here what we have done is that to estimate the power loss due to soiling of the surface of the solar PV panel, we have come up with a multimodal approach where we have image processing combined with environmental factors processed by a deep learning neural architecture to predict, to give us estimate of the output that we can get from the solar PV panel. So this is actually a very interesting way to deal with this, and I won't go into the details because a lot of this work is already published in papers that we have. I can send the references, but what I want to show is that we have a huge image processing part, and we incorporate the environmental factors and process it in a deep learning neural network framework. The quantile score, which gives us the estimate of what is the output like in the probabilistic forecasting framework. The proposed method performs excellently well, and compared to many of the other methods that we have benchmarked against, the results are really good. Not only it gives us much better results, but the confidence interval of the forecast, that the forecast will be most likely 90% likelihood of forecast falling within a certain range is also there, which means overall we are able to forecast with much better certainty. Now, one of the issues is that this was good, but then our collaborator wanted to see whether we could further improve the images that we were capturing. So we actually did further image correction and reconstruction. And this is the framework that we used. We did a lot of image enhancement. So here what I want to highlight is that even though the problem is that of power systems and forecasting of solar PV output, we have leveraged quite substantially on the knowledge and advancements in image processing field to improve the images and get better forecast. And the results are shown here. So with the method that we developed, we are able to get much better forecast with small error. And this is the RMSE. And compared to other benchmark models, it's much better. Then we did ablation studies to see the impact of each factor one by one. And in this figure, the green line shows the forecast produced by our model. And again, you can see that it's actually tracking very closely to the actual power output. Now, all this is good, but then the question is, the whole process of making decisions, the processing of the images is happening on the cloud. And that's not very practical, because if you imagine what we are doing is that we're collecting information from the field, sending it to the cloud, running the algorithms there, and the decisions are then transmitted back to the field. This causes a lot of communication cost, and there's also high latency. Not only that, there are privacy concerns because you are collecting the images and sending it to the cloud. So the next question was whether we can take it to edge computing and do everything on the site itself. So we investigated this and deployed it for the collaborator that we are working with. So the idea was that we move everything to edge computing so that we can reduce the latency. In fact, there is no latency if all the decision making is taking place at the site itself. There are also no privacy concerns, and this is a much better solution. So the framework looked like this. And in this, what we did was we actually used a variation of mobile net, which is a lightweight model optimized by Google for edge devices. And we made improvements on that mobile net to develop what we call as Solar Edge. That's our model. Now, in this, we are able to extend the model to edge computing. And again, this is something very new in the field, where we have taken everything that was being done on the cloud earlier. We have trained the models, of course, on the cloud, but the trained model is now deployed on the edge device in the field itself. And we tried many different edge devices from Intel and from Google. They have different pros and cons. The Google devices tend to be much more expensive compared to Intel devices. And we finally ended up deploying everything on Intel VPU. The results of our work are shown here. So again, one of the benchmark models is ResNet, and we compared our results with ResNet, and it turns out that we are able to get excellent results which are comparable with ResNet's results, but we are able to do it in a much smaller inference time. That means the processing is happening in almost real time, which is a great benefit. Another issue with which our collaborator was facing was that they wanted to know more about what was happening on the solar PV panel. And this collaborator is actually a large operator that has several grid scale solar PV farms. So they are able to invest money in developing these techniques and deploying on the edge all of these expensive edge devices. But they also wanted to have a bit more information about what was happening on the panel. So adding explainability was the next thing that we did. And we used saliency map to add the explainability to tell more about what really was going on, what was the type of problem that the solar PV panel had, what kind of soiling was taking place, and so on. Again, in the interest of time, I won't go into too much of detail on this, but we were able to then work with this company, collect a lot of images, and then identify what kind of problem had taken place, what was the extent of soiling on the panels, and what to do about it. Again, all of this adds a lot of uncertainty in the decision-making process, because all of these things are challenges which are faced in practice. So in this, we again developed the approach, and then we moved it to the edge, and we deployed it on edge devices. So again, similar to the previous model, we have now managed to not only provide better estimates, but also have explainability included in this. Now, another type of input that is very often used to predict solar PV output is using sky camera images, which tracks in terms of cloud movement, how the solar output is likely to be from one instant in time to another. So again, what we have done is to extend the sky camera derived irradiance forecasting to edge computing using a framework that is similar to Solar Edge that I just talked about. So again, the processing can be very, very computationally intensive, but what we do is to do all the processing on the cloud, train our models. These are all deep learning models, and then we transfer that learning on edge devices to make real-time decisions. So this model is called SolarGAN, where we've used a generative adversarial network to do processing, and we also do data imputation. Now, data imputation refers to something quite interesting. When we're collecting a lot of data from various inputs like weather indices, from the pattern of solar PV output from a given power plant, and there are lots of other things such as irradiance, wind speed, humidity, and so on. A lot of the data that is collected, when it's sent to the cloud, a lot of it goes missing. In fact, 40% of solar data is lost due to transmission issues. This causes a lot more uncertainty. Again, this is a new type of uncertainty that people don't normally talk about. So in this figure, such a scenario is shown where all the yellow boxes show missing data. And this can be very, very high, depending on noise and other factors. So the next question we had was, what can we do about this kind of uncertainty? So we have extended the generative adversarial network that we developed to also do data imputation. By imputation, what we mean is that we estimate the missing data. So here we have used a technique where we sum the real samples and random noise in order to predict what is it that may be missing. And this data imputation approach, again, has been very effective. The red curve here shows the results from our model, and we have compared it against other benchmark techniques which are commonly used for data imputation. And again, the results are very impressive. So let me just take 5 more minutes to talk a bit more about other types of uncertainties. Similar to solar systems, like I mentioned, wind power systems also face a lot of uncertainty because of different issues such as data quality and availability, the need for advanced models, uncertainty which is inherent in the wind itself, and computational requirements. One of the other issues is that before a wind farm is actually commissioned, you need to do data collection for over 10 years to see what is the pattern of wind from year to year, from day to day, and from hour to hour at that location. And that data is then used to estimate how big a wind power plant can be commissioned there, how much power can it generate. But that becomes very challenging because you may not have so many years to collect the data. If you find a good windy site, you want to make a decision about whether or not to install a wind farm there very quickly. So again, working with another collaborator from China, which was evaluating potential sites for installing wind power plants, they were actually trying to see how we can speed up the whole process. So we worked with them in order to use an approach called transfer learning approach to do wind forecasting in new sites where there is really no data that is available at the site. And here we have used, again, a neural network based model, deep learning model. It's by LSTM model, and this is used for short-term wind forecasting. What we did was that we used just short-term data collected over 6 months to a year to get the general idea about the pattern of wind that is there at that location. We then matched it to an existing wind power site where a wind farm has been operating, has been producing power, and for which many years of data was available. We used deep learning models to do the matching of the data collected from the new site to the existing sites. And they are in China, since there are lots and lots of wind power plants, you can match it with many different locations. We found then a good match where the new site and the old site have very close correlation. And then using the data from the old site, we did transfer learning to develop forecasting models for the new site. So this is something quite interesting and quite novel. And here we're really talking about the issue that it's not missing data, but it's no data at all. And again, using transfer learning, we are able to produce much better forecasts. I won't go into the details of this, but let me move on to capturing the uncertainty in user demands. Again, it's very, very important to predict the demand that we will have from various users. And this has to be done for various time frames, for various applications within the smart grid. At a second to millisecond level, we need this information for demand response. At a few hours to 1 day ahead, we need it for scheduling. And then larger time frame is needed for system planning and determining the policy. Now, this kind of accurate forecasting has a very huge impact on the cost. A 1% improvement in load forecasting accuracy can result for a 1 gigawatt peak utility. A 1% improvement can result in $500,000 per year of savings for long-term forecasting and $300,000 per year of saving for short-term load forecasting. So you can see that it has huge impact.
Apologies to interrupt you, Dr. Srinivasan. Due to the time constraint, please conclude.
Sure, I will do that very quickly. So just some results on how electric vehicles also add a lot of uncertainty and how can this be managed. And we have used multi-agent systems to model a large community with industrial, commercial, and residential users with a very large number of electric vehicles and how the uncertainty can be managed. Let me just go to my last slide. So data, or second but last slide. So data analytics is actually very important for smart grids and is becoming increasingly more important. Machine learning combined with data analytics can be used for making intelligent decisions in the grid. How will AI-based data analytics modernize the grid? Well, there are many different ways in which actually it's going to help. And again, we have a lot of data collected. We have very sophisticated algorithms, and through our experience, we've been able to see how they have actually helped the grid operators. And through this, we can adopt higher levels of renewables. So the key takeaways are that uncertainty is a central challenge we cannot avoid. It is going to keep on growing. That also is something we cannot avoid. But we have solutions from data analytics and from AI, machine learning algorithms, and hybrid and probabilistic models can improve decision making and grid resilience. So with this, I'm going to conclude, and I would be happy to take questions if they are in future.
Okay, so thank you, Dr. Deepti. I'm Dr. Tiwari speaking this side. So thank you for giving a very informative talk. And when we are moving towards the sustainable world, RES is going to play a very important role, and forecasting and probabilistic model is going to play a very critical role, because wherever is the uncertainty, we need to do the probabilistic model, mathematical modeling is required. And there the AI and machine learning is going to play a very important role. So bringing this all the facts to our participants and the students, we are very thankful and looking forward to see you more interactive presence here in physical. If you are coming sometime in India, we would like to welcome you in the Amity campus. Thank you very much.
Thank you very much, Dr. Tiwari.
Thank you.
Thank you, Dr. Srinivasan, for your perspective.
Our final keynote speaker in this session is Professor Dr. Stephen L. Smith, Professor of Electrical and Computer Engineering at the University of Waterloo and Canada Research Chair in Autonomous Systems. He co-directs the Waterloo Artificial Intelligence Lab and leads the Autonomous Systems Lab with impactful contributions in control, optimization, and robotics. He will speak on planning to push, robot motion planning in environments with movable obstacles.
Over to you, sir.
Great, thank you. Thank you very much for the introduction, and happy to be here. You can see my slides fine? I think so. Yeah, okay, thank you. So what I want to talk to you about is some work we've been doing in robot motion planning in environments with movable obstacles. So first, let me give you just a bit of context. So my research lab is called the Autonomous Systems Lab at the University of Waterloo. And we work in problems like coordinating large multi-robot teams, long-term persistent autonomy in uncertain environments. We do work in solvers for large-scale routing and planning problems, and also learning-based navigation for adaptive, high-performance autonomy. And the applications of this are fairly broad. We look at problems in transportation and mobility. I'll talk to you a little bit about a particular case of this, human-robot interaction, environmental monitoring, and then even problems like robot coverage for cleaning or inspection tasks. So on the bottom right here is a picture of my lab. But what I want to talk to you about today is this idea of planning to push. So let me just motivate what I'm talking about. So as mobile robots start to be deployed more in cluttered real-world human environments, they encounter obstacles that can be moved. And as humans, we naturally navigate through these environments and we move the obstacles to get to our desired goal. So you can see here, this is a robot that might want to navigate to the far side of these chairs, but to do so, it might have to push a chair to the side. So for these types of environments, the robot must interact with the environment to accomplish its tasks. And we call this interactive navigation. A common approach to do this is that you would put a mobile manipulator, like a manipulator arm, on top of the robot, and then it could use this arm similar to the way a human does to move an object to the side. However, there's many cases where that might not be possible. So one is that it can be challenging to do this prehensile. Prehensile means like you have a gripper, a hand, essentially. But you can do prehensile manipulation with complex objects remains challenging. Like imagine you're trying to move a large box or something like this with a manipulator arm. The other thing is, as you can imagine, not all robots have a manipulator on them. And so in this case, you still want to interact with the environment. So here's another example. There's like a cluttered environment with some boxes on the ground, and there's a quadruped robot that needs to get around them somehow, and there's not enough space. Down here, you have some robots that are trying to push these different boxes into a goal region. And in the right, one that I'll talk to you about, which maybe you haven't thought about before, is in northern climates, when you're trying to have a ship navigate through like the ocean, the water freezes and you get these like pieces of ice floating on top of the water, and the ship has to try and safely navigate through this, pushing pieces of ice to the side. So this is this area of non-prehensile meaning we don't have a gripper or we don't have an arm, interactive navigation, interactive in that we're pushing things. So what I'm going to talk to you about today is kind of three pieces. The first is the first work that got us started in this planning with movable obstacles. In particular, we look at this problem of ship ice navigation that I showed on the far right. And the main contribution here is an energy loss optimizing planner for an autonomous surface vehicle to navigate in these icy waters. The next one is that one thing that happens is when you're planning to push objects, you would like to predict what's going to happen. And this involves predicting kind of complex physics. And so we have developed some learning-based methods to predict physics and then integrated them into planning techniques so that we can have these learning-based planners. And then the last is that we've done some work on sort of a more generalized benchmark that has a bunch of different tasks that are in this like pushing kind of space. And so I'll tell you a little bit about the types of tasks that we've been looking at and what can be done with this benchmarking software. So let's start with this autonomous navigation in ice-covered waters. So in the Arctic, this is what it might look like at some point in the winter. So you can have big sheets of ice, or in many places you can have these like broken up pieces of ice that are called ice floes. There's a lot of potential for having ships travel through these types of environments because they offer shorter shipping routes, and there's also rich natural resources up in the north, and there's also an increased interest in tourism there. However, as you can imagine, this is a high-risk navigation scenario. If you make contact with a piece of ice that can damage the ship, it could be like catastrophic. So we've been working with an industrial partner on autonomous surface vehicles that can safely navigate through these waters. So let me just first show you, if you're not familiar, this is an example of a ship navigating, like a real ship, not autonomous, navigating in this type of environment. It's sped up. You can see how it's not that the ship can avoid all of the ice, right? It's not an obstacle avoiding problem. It's instead trying to sort of find gaps between ice and push ice to the side and not make big contacts with large pieces. And so the question is, currently when this is done, it's done by an expert who's driven, piloted a ship in these types of conditions and knows how to navigate safely. But we would like to do this in an autonomous manner. So let me just kind of formalize what this problem looks like. So you have a ship. We'll model just the ocean surface as a 2D plane for right now. We won't worry about like waves and things, but this wouldn't be a big problem. And consider like the ship has 3 degrees of freedom. So it has a position, X, Y, and then it has a heading, which we call the yaw angle, which is this angle psi. And so combine the state of the ship is this X, Y, psi. And then the environment that it's trying to travel in looks something like this. So you have a ship and then you have a bunch of different pieces of ice. Your objective is to travel down to a goal. And so we model this environment as like a long rectangle, long wide rectangle. And there's a bunch of different ice floes or ice pieces, and they're each treated as an obstacle in the environment. And your goal is to reach the end of the channel, which is this green line. And typically the way we do this is by like identifying intermediate goals. So you might want to reach the orange line. And then once you reach it, then you plot like another orange line, another distance of delta H ahead. You plan to it and you continue until you finally reach the green line, which might be, several kilometers away. So there's 2 main costs associated with navigating in this type of environment. We write the overall cost as this linear combination, where the first cost is just the path length. So you think about how long is the path that the ship takes. We would like the ship to take shorter paths that's more efficient. And the second is the collision cost. It's some way of capturing what's the additional effort that the ship exerts in order to collide with the different obstacles or the ice floes in this environment. And then we have this, parameter alpha that trades off the magnitude of these two different costs. And so the overall formulation is that we want to compute a trajectory from this initial robot pose or ship pose up to the goal line that minimizes this cost. So a lot of the challenge is in how do we compute this second cost, right? The length is clear, but how do we do this second one? So I'm going to propose to you a planning framework that, and then how we've, two different ways that we've been computing these types of costs. So the planning framework is what's called a lattice-based planner. And it looks like this. So you basically have a bunch of different motion primitives for the ship. So the ship is being shown here. And each one of these pink lines is a different motion primitive. The ship could go straight, it could make a left turn, it could make a left turn followed by a right, and so on. And then to plan a longer motion, it would basically repeat, like concatenate a new motion primitive to the end of the first one. So it would just plan out a sequence of these motion primitives. So this might look something like this. Here's the ship, it's currently located here. The black lines are the first set of motion primitives. And then at the end of each one of those motion primitives, we draw another set. And now we're going to plan in the resulting graph. Okay? And so this then the nice part about this is planning then can then be cast as a kind of normal search problem over a discrete graph. But the question is, how do we compute costs for different options in this graph? The path length is easy. We have a path length associated with each individual motion primitive, and so we just sum up the lengths of the motion primitive to get the cost or the length of the overall path. To compute the collision cost, though, I'm going to kind of show you just a few intuitive ideas that hold for ship navigation in ice. The first is that if you were to consider these two scenarios, one is where the ship collides. You can see that the path that the ship, if I draw the path that the ship's taking, which is the red line, through the obstacle, it's the same on both sides, but the obstacle is much bigger on the left. In this case, the force that the ship will experience when colliding with the ice on the left will be larger, and so we would consider this to be a higher cost than the one on the right. So whatever our collision cost looks like, the left should be evaluated as higher than the right. Similarly, we should have a higher path cost for more head-on collisions. So if we consider these two scenarios, one where you pass through the center of a piece of ice, and the other where you just graze the edge, we would like for, again, the cost of the left path to be higher than the right. And the other thing is that there's generally going to be a higher path cost for collisions in higher ice concentration areas. So let's not worry about the formula for a moment. But if you consider colliding with this piece of ice here, when there's a bunch of other pieces of ice around it, that has a higher cost because there will be more resistance on this piece of ice due to it now interacting with the ones around it than the scenario on the right where it's colliding with that piece of ice and there's nothing around it. Okay, so we've kind of formalized these different ideas into an overall collision cost. I won't show you the final formulation, but with this now we have this lattice-based planner that can evaluate both path length and collision cost, and we can now deploy this on an autonomous vehicle or autonomous surface vessel to navigate through ice-covered waters. So we've done a lot of both simulation and some real-world experiments that I can show you for this. So the ship that we're considering is what's called a platform supply vessel. This is used typically to resupply offshore oil rigs that are extracting oil from the ocean floor, or also there are some other applications of them. And we did a total of 1,200 trials with 100 different ice fields, 4 different ice concentrations, that's just how much ice is in the environment, and 3 different planners. So these are some examples of what the ice fields look like. The top has the lowest concentration and the bottom has the highest concentration. And we considered 2 main baseline methods. One that makes a lot of sense was is what if you don't do anything fancy at all and the robot or the ship just drives straight through the ice? So this is the straight line path. We should hopefully see an improvement over this in terms of collision cost. And then another is something which has been proposed in prior work called the morphological skeleton planner. The idea of it is you can compute something called a morphological skeleton of the open water area. It more or less defines a graph that where vertices are places like pieces of open water and edges show paths between these open water locations. It doesn't have the same kind of sophistication as the proposed plan we're thinking of because it can't the impact of collisions with the ice. It instead tries to just split between all the different pieces of ice during its plan. So we ran these planners across 1,200 different environments, as I mentioned, and this shows what the resulting forces that were experienced on the ship. So the top is for the straight planner. What you're seeing is that each line gives a point where a collision occurred on the hull of the ship. The length of that line gives you the magnitude of the force on the ship. And so smaller is better, basically. And you can see that for the straight line planner, you're getting a lot of like high force impacts right at the nose of the ship, right at the front. The skeleton planner is doing better. It has a lot less head-on collisions, but is still experiencing fairly high forces along its hull. In comparison, our proposed lattice planner has much lower forces all around the hull. And these are some examples of what the behavior looks like. So this is just the straight path, right? It does as you expect. You could see it can kind of collide with big pieces of ice and end up pushing them for a long period of time. In contrast, the skeleton planner, which is this one from the prior work, nicely tries to go between pieces of ice, but it doesn't really prioritize large, like places where there's large pieces of ice. Like still it makes a fairly big collision with this big piece of ice versus smaller pieces of ice. And then the proposed lattice planner, which prioritizes avoiding these large pieces of ice, I mean to say, and navigates, with lower forces being exerted on it while still having a short path to the goal. So we've also here's another result where we kind of classified the environments into using someone who knows about ship ice navigation, classify the environments into easy, medium, or hard based on the ice configuration. And then this is a comparison of the three planners. And the thing that you might want to focus on is on the right-hand side, where the ice configuration is what an expert would consider to be hard. And the vertical axis is the work done by the ships. So this is a measure of like the collision cost. You can see that the proposed planner, the lattice-based planner, has much lower forces exerted on it than either the straight planner or the skeleton planner. When the environment is what's considered easy, you don't see much of a difference between the straight planner and the lattice planner, but that is kind of as expected. So as a result, you're seeing improvements that get up to about 50% in terms of the efficiency of the ship navigating in these waters. The last thing I want to show you is we've actually also done experiments in a test facility at the National Research Council of Canada in St. John's, Newfoundland, which is on the east coast of Canada. And this shows a model ship. It's about 8 feet long, I would say, or a little over 2 meters long, navigating in ice-covered waters. The left-hand images are like the reconstruction using an overhead camera of what occurred. And so we've done a bunch of trials in this, evaluating the different planners as well. Now, one thing that work does not do is it tries to evaluate the cost of a path, but it doesn't predict forward what will happen when the ship interacts with the ice. So we would like to predict how the ice will move in response to the ship. One thing that we observed is that at times the ship will identify an area of low ice concentration, but by the time it gets there, it's pushed a bunch of ice into that area, and as a result, it doesn't actually get a lower collision cost. I'm also showing on the right, one thing we also experienced is that while the test facility on the east coast of Canada is amazing, we have very limited access to it. And so we also created what we call a dry land test bed. So this is a wheeled robot. It's in my lab at Waterloo. We created a bunch of ice pieces, which are not real ice. This is a solid floor instead of water. But we can still have these pushing type tasks. And so this is a wheeled robot navigating through then these kind of not real pieces of ice, let's say. But what we want to try and do here is predict forward the physics of the interactions. So our idea for doing this is to learn a model of the physics. One option could be that you could try and actually just use a physics simulator and simulate forward all the collision dynamics, basically. But the problem is that you're trying to do this inside of a planning loop. You're trying to evaluate many different paths for the ship, and for each one evaluate its collision cost. And so running a physics simulator inside of your planning loop is not feasible. This motivates the idea of using a learned approximation of that physics model. So this is what the sort of overall architecture looks like. We're using the same type of lattice-based planner to plan different paths. That path and ice configuration is fed into a neural network, which is a UNet. It predicts how the ice will move in response to that particular path. That then provides a cost that goes back into our motion planner that can then evaluate different paths. And this process continues where we're generating different paths, evaluating them with the learned prediction method, and then continuing the search until we finally find a path that reaches the goal line. So the learned predictor is integrated into a graph search planner to compute paths. The idea of the ice motion predictor is as follows. So we have this long channel. Here's the current ship location. We crop out a local occupancy observation. So this is what the ice looks like locally. That gets copied up here. We also have a mask that shows the footprint of the ship. So you can see that corresponds to the blue location of the ship in this red box. And we have what we call a swath, which is this is the path that the ship is trying to evaluate. And the swath shows what area would be swept out by the ship as it followed that path. These three channels go into this neural network, and what comes out is a prediction of what the ice configuration will be at the end of this motion primitive. And then what we can do is we can compare what did the ice look like initially versus what we predict it to look like after we execute this motion. And from that, we can extract a collision cost or a better cost of that particular path. So we train this on our physics simulator using a bunch of data. And with this, we can get quite good predictions. And then we use this, to update the global occupancy map, and with this, continue our plan. So let me show, this is now on that dry land test bed. The top is now this planner that integrates this prediction, and the bottom is the lattice planner that I talked to you about in the previous part. And one thing that you can see, and this kind of describes exactly what I'm talking about, the bottom, the lattice planner here has kind of identified this open area. And so it plans to navigate towards this open area because it has low cost. But you'll notice by the time it gets there, it ends up pushing all these ice pieces into that area, and it's not open anymore by the time it gets there. The prediction-based planner that uses our learned predictor, on the other hand, can figure that out. And so it instead takes quite a different path. You can see that they started at the identical configuration in this case. We were able to reconstruct the exact same environment configuration. So the predictive planner is nicely kind of parting the ways between obstacles, where you can see the lattice-based planner ends up pushing a bunch of ice into the open area that it was trying to reach. On the right is a plot of the approximated work done by these two robots when navigating through this environment. The blue is higher, it's the lattice planner, and then this predictive planner is kind of the improvement, right? You can see it's using significantly less energy to navigate through the environment. Okay. So this is where we got started in these pushing-based tasks. But there's actually a lot of other pushing tasks that we've been interested in. And so the last thing I'll talk to you about is this benchmark that we've been developing. So in other areas of robotics, benchmarks have been very useful. So in fields like locomotion, visual control, they've benefited from having these standardized simulation environments where different people can evaluate their algorithms. But there does not exist that kind of benchmark for pushing-based tasks or non-prehensile interactive navigation. There are benchmarks that focus on collision-free navigation, but that's not applicable for us because we want to consider cases where the robot has to interact with the environment. So we've developed something called Bench NPIN or Bench Push, which is a suite of tools for benchmarking non-prehensile interactive navigation. It includes simulated environments, metrics that you can evaluate different algorithms, and baseline implementations of different algorithms. So we consider two types of tasks. One that we call navigation-centric tasks. These are tasks where the robot is trying to reach a goal, but in doing so, it has to interact with the environment. So the top one is like a maze-like environment where the robot might have to push some of these orange blocks to reach the green goal location. The bottom is the ship ice navigation that I talked to you about. And then we have these other set of tasks, which we call manipulation-centric. So that was maze navigation, ship ice navigation. And then we have one which we call box delivery, where instead the robot's goal is to push all the orange blocks or boxes into the green goal. And also area clearing tasks, where the goal of the robot is to push all of the boxes outside of the green area, right? You're trying to clean the floor and push everything to the edges of the room. So for this, we have different types of environments. We can add in static obstacles. So these gray objects here are static obstacles that can't be pushed. Same with these walls, and so on. And so this is kind of the suite of different environments. And let me just show you what some of the simulations look like. So this is a maze with movable obstacles. These are different types of environments that are in here. And so you can see in the left, the robot doesn't have to interact very much with the boxes in order to navigate to the goal. In the Z-shape one on the right, it has to interact more. We have this one, which you're familiar with now, autonomous surface vehicle navigation in ice-covered waters. And this is just showing different ice concentrations going from very sparse ice to very dense ice concentration on the right-hand side. This is the box delivery task. So here the robot is trying to push all these boxes into the goal region. And what you're seeing here is a reinforcement learning-based planner called spatial action maps and its technique for doing this. This is a fairly challenging task, especially when you have these static obstacles in the environment as well, like in the middle and the right scenario. But the objective is to deliver all the boxes to the receptacle, the green region. And in this benchmarking, you can adjust many different parameters. Okay. And then the last one is this area clearing. So here, the goal of the robot is to try and push everything out of the green boundary. The left one is the most simple, In the right one, there's walls that close in the environment on the left and the right. So the robot has to push objects out either the top or the bottom. And the right is the most complex. It has that same walls on the left and the right, but it also has some static obstacles within the environment. Okay. We also have metrics that evaluate the robot performance. And these take the form of efficiency scores and also interaction effort scores. So they'll evaluate things like, let's say we have these 3 different paths that take you to the goal. The blue path is the longest, so its efficiency score is fairly low, 0.5 in this example, but its navigation score or interaction score, I, is high because it doesn't have any collision with the boxes. At the other extreme, the shortest path has a much higher efficiency, closer to 1 being the best in terms of reaching the goal, but it collides with several boxes on its way to the goal, and so its interactive efficiency is much lower. And so with these different metrics, you can kind of compare different planners and how they are operating in the environment. Okay. And we have a bunch of different baseline algorithms implemented in this benchmarking software. So these include, they're mostly learning-based methods. So this is soft actor critic for both the maze environment and ship ice, or for all the different methods. We have PPO, which is proximal policy optimization. It's another reinforcement learning technique. We have spatial action maps for box delivery and area clearing. And then we have some domain-specific planning policies, like for ice, ship ice navigation, the lattice planner, and the learning-based lattice planner, and so on. So this is available as a GitHub repo and a Python library. We're currently developing this, so it's under development. And one thing is that I think the name will actually change from bench npin, which is kind of hard to say, to just bench push, to be a little bit more direct. But in any case, that's sort of what I wanted to talk to you about. To kind of recap, I mean, the main contributions I talked about have to do with planning with movable obstacles, modeling complex interactions, and this development of a benchmark where people can develop new algorithms for planning to push and evaluate them against existing state-of-the-art. Where I think things are going, I mean, I think this is quite a rich problem. And so one thing is that it would be interesting to explore diverse interaction modalities where robots have to deal with a wider spectrum of interactions. So interacting with different types of objects, different materials, things like this. And how well do policies that we train on a simpler environment, how well do they transfer to a more complex environment with more interaction modalities? The other is when there's more uncertainty or partial observability in the environment due to onboard sensors, things like occlusions, and so on. And the last is what's the role of things like foundation models for understanding environments and providing context, and things like vision language models, vision language action models, and how could these be kind of used to inform inform pushing methods. So I think that's all I wanted to talk about. Thanks for listening, and happy to take any questions if there's time.
So, thank you, Professor Smith. It's always pleasure to listen you. I'm listening you, I think that 3rd or 4th time. And whenever you come, you bring a very novel and informative talk. And many of our undergraduate students are sitting in this hall, and they are having a fantasy of doing the work onto the robotics. And they normally do a work onto where the obstacle is constant, not moving, but you brought a new concept here that when the obstacle is moving, that how to design a robot that is navigating the obstacle also. So I'm just recalling one concept when I was teaching to the master students robust control theory. There was a topic that is Markov decision process, right? Partially observed Markov decision process. So is this the work that you were presenting? I think that is very close to that. You can comment onto it to make me more wiser onto this shortcut.
Yeah.
Yes.
No, that's a great question. Yeah. So when in the later parts where I was showing these different baseline algorithms, they basically all model the environment as a Markov decision process. So and it might be partially observable if you can't, for example, if you have onboard sensors and so you can't observe all of the ice pieces. And so that's exactly right. Like it's a giant Markov decision process. So you typically don't like write down the whole thing explicitly, but you have a model of what's the set of actions that you can apply, what are the rewards associated with actions, and then they make transitions to new states for the robot that have some uncertainty associated with them, and that's how you get the basis of kind of training these different reinforcement learning policies. So yeah, you're exactly right.
Yes, thank you. And one last question: that when you are coming to India?
Oh yeah, I'd love to come to India, but I have no immediate plans. But
okay,
yeah,
whenever you have a plan, please write me an email. I would love to host you. Right? Thank you.
Yeah, well, thank you very much, and thanks again for having me. It was a pleasure.
Thank you. Thank you. Okay. Thank you.
All right. Bye, everyone.
Innovation distinguishes between a leader and a follower. Thank you, Professor Smith, for your valuable insights.
With this, we conclude plenary session 2. On behalf of organizers, we extend our heartfelt gratitude to our esteemed speakers and our faculty coordinator, Mr. Kamlesh Pandey. Knowledge is power, but enthusiasm pulls the switch. Thank you for being a part of this journey.